Hi, welcome to Coding Bootcamp's YouTube channel. Subscribe now and join our live stream session later. See you.
Hey guys, welcome to coding-bootcamps.com. Be sure to follow us on social media such as LinkedIn, Facebook, YouTube, and other social media platforms. Today we're going to be talking about the course we have available, which is Introduction to Linux Bash Scripting. We're going to start off with a little bit about myself. My name is Kevin Downs. I'm going to be the instructor for this course. I'm a Red Hat Certified System Administrator, or RHCSA. At my current job, I'm in charge of administering hundreds of Linux servers across multiple different distributions. I work as a Unix system administrator supporting several large enterprise-level clients with IBM across multiple environments. As an RHCSA, I'm adept at Linux programming for both personal and server Linux systems. I'm also pursuing my Red Hat Certified Systems Engineer and DevOps. Let's go and talk a little bit about this course. So the prerequisites for this course is Introduction to Linux OS. Guys, if you have not taken this course yet, be sure to follow this link, complete that course. Once you've completed that course, go ahead and come back to this course and you can take this one. The things we discuss in this course are built upon the foundations and concepts we lay down in this course. So without this course, you're going to be a little lost as to what's going on in this course. It's crucial that you complete this course first. Some of the topics that are going to be covered in this course are basic user commands, intro to shells and fish bash scripting, shell programming, advanced shell features, text manipulation utilities, networking commands, and we're going to have some hands-on projects. The first one's going to be bash scripting with 12 hands-on examples. Then we're going to do a grep command project with 10 hands-on examples. And then we're going to have you write your very own bash script. Okay, so after completing this course, you should have all the tools and knowledge necessary to be able to write this script on your own. So what's the takeaway from this course? What do you get by completing it, and what's going to happen after you finish this course? Well, by completing this course, you'll be able to go out there and pursue a career, whether that's in development or system administrator, IT specialist. Any of those jobs are going to require some form of scripting knowledge. Okay, so by having this base knowledge available to you, you're going to be able to go out and feel confident looking into some of those careers and getting your foot into some of those careers by learning these necessary skills of scripting. Okay? So some follow-up classes to take after this course are Learn PHP Programming, Intermediate Level Linux Bash Scripting, which is a course I'll be instructing as well, Linux Management for System Admins, which is another course I'll be instructing, and Intro to HTML and CSS. Be sure to follow us on Facebook, LinkedIn, YouTube, and other social media platforms, and check out our other courses on coding-bootcamps.com. And I'm looking forward to seeing you in this course and on the next session. What's up, guys? Welcome to the first session of Introduction to Linux Bash Scripting. As always, I am your instructor, Kevin Downs. For this session, we're going to be talking about Intro to Linux Bash Scripting, okay? So a little bit about myself. I'm a Red Hat Certified System Administrator, or RHCSA. At my current job, I'm in charge of administering hundreds of servers running on different Linux distributions. I work as a Unix System Administrator supporting several large enterprise-level clients with IBM across multiple environments. As an RHCSA, I'm adept at Linux programming for managing both personal and server Linux systems. Currently, I'm pursuing my Red Hat Certified System Engineer and DevOps. So guys, a little prereq for this class is the Introduction to Linux OS class. A lot of the things that we cover in that class are necessary and foundational knowledge for what we're going to be talking about in this class. Okay, so be sure to follow this link here, take this course. Once you've completed that course, go ahead and come back and start on this course that we're doing now. So we're going to be going over some basic user commands here. So session 1 outline. First thing we're going to be talking about is basic user commands, logging in and logging out, command line editing, navigating the file system, viewing and copying files, and controlling the terminal. So let's go ahead and talk about logging in and logging out. So when you first start up Ubuntu in GUI or GUI mode after installing it, you should see a login screen window. If you do not use Ubuntu from GUI, then you need to enter your username and password on the initial screen you see to log in. Okay? So you can actually log in and out on the terminal itself, okay? And we could type gnome session quit, and this is going to log you out via the command line. Or you can do a force logout, which is gnome session save -- force logout. Okay. One other thing you can do on the desktop is you can use not listed and log in as root, and you can actually log into root that way. So let's go ahead and head to my virtual box here. And I'll show you what I mean there. Let's get it powered on and booted up. Actually, while that's booting up, I want to talk about the next slide here, and that's how to actually turn off the system and halt it and reboot it. So it's actually a pretty simple command that you can type in. You just type in shutdown on the command line, and it'll boot your or turn your system off. However, take note that this command doesn't shut down the PC immediately. Instead, it ticks a timer and gives you one little time to save all things. Okay. So if you need an immediate shutdown, you want to use the command below, and that's going to be sudo shutdown-p now, and P stands for power off. Okay. Alright, now let's go ahead and head to our virtual box here. So that first thing I was talking about, so we see this not listed here. I can type in root, and then my password for root. And guys, this is CentOS, not Ubuntu. So now it's going to log me in as root. Adjust my screen here so you guys can see everything. And then from here I can go to my activities, type in cmd, and open command line. Okay. And then from here, if I wanted, I could type in that power off command. Okay. I'm not going to do that though because I don't want it to actually shut down my system. I want to go ahead and show you guys a couple other options we have with that shutdown command. So you see here, this is the basic syntax of that shutdown command. We have the command shutdown, then we have the options to it, a time if we want, and then a wall message, okay? So like I said, shutdown can be used to halt, power off, or reboot the machine. And the first argument may be a time string, although it's typically going to be now is what you're using. And then optionally, this can be followed by a wall message to be sent to all logged in users before going down. So this wall message, guys, is just a message that will display across all the systems and everyone using the system. Or I shouldn't say the systems, but all the users on the current system are going to get that message, whatever it may be. So the time string may be in the format hours, :minutes. And you're doing that to specify the time to execute the shutdown at. And it's in a 24-hour clock. So if you want to do 2 o'clock, it would be like 14 instead of just 2. Okay. And guys, note that you need, or in order to specify a wall message, you must specify a time argument too. Okay. Let's take a look at a couple of the options here for shutdown. We have -- help, which we should be familiar with. So it'll print a short help text and exit. -H, which will halt the machine, or -- halt, the full word. -P, which will power off the machine. And this is default option, guys. And -- power off will do the same thing. We also have -r, or -- reboot, which is going to reboot the machine. And -k. This isn't going to halt, power off, or reboot the machine, but instead just write a wall message. And then we have -- no wall -wall, which won't send a wall message before halt, power off, or reboot. And then we have -c, which will cancel a pending shutdown. So if you have it set up to shut down at a certain time, you can do a -c and it'll cancel that shutdown. Okay. So real quick, I'll just show you the syntax on our virtual machine. So it's going to be a shutdown, and then -k or -h. Okay. Or we can do -k, we can do 12:33, just like it said. Okay. Oops. Alright, so that's kind of how you would do the shutdown command. Again, I'm not going to do it just because I don't want it to actually shut down my machine. That is how you do it. Alright, back in our PowerPoint here. We're going to be looking at navigating the file system. So let's go ahead and talk about navigating the file system here. So Linux file system will be unfamiliar to Windows users, but Mac users may recognize it. And guys, this will kind of be a review for us from that intro to Linux OS system, okay? So the files are held in a tree structure with root denoted by the / okay? So that's the beginning of all files. Don't get this confused with the user root, okay? This just simply means the beginning at the top. So each directory under will be preceded with another / and followed by a / to denote the beginning of the next directory. All files and commands in Linux are case sensitive, okay? So documents with a lowercase d and documents with a uppercase d are actually two different files and directories, okay? Directories are separated in a path using the / character, okay, or the root of it, just as we talked about up here. So there's different file types in Linux. We have ordinary files such as text files, data files, command text files, which are scripts, and executable files. We also have directories, and then we have links such as hard links and soft links, okay? So rather than having multiple copies of a file, Linux uses linking to one file to save disk space. So we can have a file, and this file can actually point to another file, okay? That way we don't have to use up more disk space for it. So here's kind of a visual overview of how that works. We have our /, which is going to be our root directory here, and under that we can have bin, dev, etc, home, tmp, user, or usr. And then we would have another / here in between all these, and we could have Bill and Patrick. And under that we would have another /. We'd have school, or books, school, okay? So let's go to our virtual box here, and I'll show you what I mean by that / there real quick. So if I do a pwd, right now I'm in my home directory, and I can do an ls. Like say I have these other things here, so let's do like a cd desktop. Okay, and I'll do pwd again. And then you see we have another / here. So I was in root, I went to desktop here, okay? And so because of that, there's a little / in between root and desktop, okay? And this is the root directory of desktop is here, okay? And the root directory of root is here, okay? So all of them are always separated by that /. I'm going to clear my screen, get some space back, and we'll go back to our PowerPoint here. Alright, so moving on, we're going to talk about the home directory. So Linux is fundamentally a multi-user system. Every user on Linux system is given a sectioned off part of the file system that belongs to them, or their home directory. So for a user named Tom, their home directory exists at /home/Tom. Whenever a squiggly line, or this is also called a tilde, T-I-L-D-E, this is called a tilde, appears at the beginning of a file path, this is shorthand for my home directory. So when Tom uses the squiggly sign or tilde, it means /home Tom, and when Fred uses it, it means /home Fred. Okay, /home/Fred. Okay, so that tilde is nice if you're, kind of far into directories and you just want to go back to your home directory. You can just put that as opposed to typing in the whole home directory path. Okay. So in this course, guys, we're going to be doing much of our work, if not all of it, on a terminal emulator. So on your desktop, you can right-click and use the Open a Terminal option pictured, or just type Control-Alt-T to open one anytime. Now, guys, this is for Ubuntu. We're going to be using CentOS for this course. Okay, so it's done a little bit different in CentOS, and I'll show you how to do that. And in this window, this opens what's called a terminal emulator. It behaves like the terminal that exists underneath the graphical interface of Ubuntu. So right now we're in our terminal. I'll go ahead and exit out of it though. So if I right click on my desktop, you'll see I don't have an option to open a terminal. So instead what we do is we're going to go to the upper left part of our screen here to Activities. Okay, we'll click on that. And we'll type in CMD. Okay? Now we'll open a terminal. So that's how you do it in CentOS. I'll go ahead and switch to Ubuntu here and show you how to do that as well on there.
Thanks for watching. Feel free to add your questions as comments down below.
Well, while that's booting up, though, we're going to go ahead and move on to our next slide, which is basic user commands. Actually, before we go into that, I do want to show it to you on Ubuntu. Alright, it's almost there. You guys, it is really important that you just go ahead and get used to using everything on the terminal, okay? There's not really a whole lot you're going to be using a desktop for, okay? As a sysadmin, you're going to kind of live in that terminal. Alright, so let's go to our VirtualBox here. There we go. Something I want to point out about Ubuntu as well is actually if you click on not listed and try to type in root, it won't let you, and that's because by default Ubuntu on the virtual machine doesn't allow you to set root. Okay, see? Sorry that didn't work. So it won't let you set root as a user, okay? So we'll just have to log in normally and then we'd have to sudo up to root if we wanted to do that. So on the desktop we can right click and now we see open in terminal. Okay? So that's how you do it on Ubuntu. Let's head back to our PowerPoint and move on to the next slide, which is going to be basic user commands. Alright guys, we're going to be spending a good amount of time on the basic user commands here. Okay? Again, some of these should be reviews, some of these may be new. Okay, and that's okay. So we're going to go through all of them. So first one we're talking about is echo, which displays print or text. It's important to encapsulate the text with quotation marks, otherwise the terminal might try to interpret some of it as a command, okay? Next we have exit, which is how you close the terminal. We have clear, which is going to clear all text in terminal. Or we can do Control L as a shorthand for that. We have mkdir, or make directory, which makes a new directory. We have rm, which will remove or delete a file. We have move, which will move files. And we have copy, which will copy files. Let's go ahead and head to a VirtualBox here. You guys can follow along with me if you'd like. We're going to talk about these. Oops. So first one we have is echo, simple enough. So it's just going to echo out the text I say to the screen. I'm going to put hello students, exclamation point. And you notice it's going to echo that to standard out, and there you go. It just echoes hello students, okay? Now, if I do hello students again without the quotation marks, it will do it. But again, just keep in mind that if you don't encapsulate it with the quotation marks, it might try to interpret those things as commands. So you always want to encapsulate it with quotation marks when you're using echo. I can do exit, which will exit the terminal. Okay, I'm going to ignore this. I'm going to open that terminal back up. Okay. Clear, so if I have a bunch of stuff on my screen here, pwt, ll, bwe, I just put a bunch of stuff on my screen. I can type in clear here. Oops. And hit enter, and it'll clear the screen. Okay. I can also make directory. So if I do an ls here, you see I have nothing on my desktop. Okay. If I do mkdir, I put test directory or tester. Now I do an ls. You see it made a directory here, right? So mkdir creates directories. Okay. I can do remove to remove files. So if I do a touch and I say test here, I do another ls. You see I have a file here named test. I can do rm test, and I do an ls, and you see now that test file is gone. So rm removes files. So I'm going to press clear here. It gets my space back on my screen. Okay, we can also move files. If I create another file called test, okay, I do an ls. So test is there. I can do move, and then you're going to name the file that you want to move, which is test. And I'm going to move that to my home directory here. So yeah. Let's see if it will actually do that. Yeah. Okay. So I'm going to cd to home. Remember, tilde is the home directory. Okay. I'm going to do an ls, and there you go. You see that test file was moved to my home directory. Now, guys, something to know about that test file, or the move command, is it's just renaming the file is really what it's doing. It's just telling the system, hey, here's where that file was stored. Let's rename it to this new location, and now this is where it's stored. That's how it's working. It's not really moving the file, it's renaming it. Okay, that is also how you would rename a file if you wanted to rename it. I could have renamed it to something else besides test. Okay, so that's also how you rename files. So let's talk about the copy command. So cp works similarly. I do cp, the file I want to copy. And let's move it to like one of these directories here. Yeah, let's move it to like let's move it to desktop. So I'll do desktop. Now I want to show you something here, guys. If I do lowercase d instead of uppercase here, right? It's going to say, I don't know what that is. Oh, well, do I have a lowercase one somewhere? That shouldn't be... Okay, yeah, see, that's not a... Sorry about that. That's not a desktop. No, that's not a location, okay? So it doesn't know where to move that. I'm going to clear my screen real quick just so we get some more space here. So I can do it copy, test. I'm going to say go to desktop. Oops. You have to spell it right, though. Everything's case sensitive. So now if I go to desktop, okay, I do an ls. You see test was there, okay? But let me go back to my home directory. You see test is also still here, okay? So it's there, and now it's back into desktop. So it actually creates a copy of the file and moves it back, or moves that to wherever you want. So you'll still have both files, okay? Whereas move actually just moves the file. You don't have two copies of it, okay? Let's move on here to our next slide, talk about some more commands. So we have PS, which will list all active user programs and display a PID of it, or process identification number. We have top, which shows an interactive list of current processes running. We have kill PID, which will stop the process with the listed PID number. We have the man command, which will display the manual for the listed command. We have cat, which displays the contents of a file. It's also used to combine or concatenate multiple files. That's where cat comes from, guys. It's the middle three letters right there. We have vim, which will open a file in the terminal-based text editor, and vim stands for VI enhanced. Okay, and then we have chmod with the accompanying flags, and this will change your set permissions to the file defined by flag. Okay, so let's go ahead and look at some of these on our virtual box. So PS, let me clear my screen real quick. So PS will list any running processes, and see we have a bash here in PS. So bash is just the shell that's running right now, and PS is that command I just ran. Okay. We can also do top, and this is a live look at all the different systems and processes running right now. Oops. Man, my mouse is going crazy on me. Hold on. There we go. Okay. Alright, so we can see all the different commands running here, how much memory they're using, CPU, and things like that, okay? Now, to get out of this, I would hit Q for quit, but notice, when I did that it left the top part of the screen up still, okay? Man, what is my mouse doing? There we go. So you see it still left that there even though it's not a live look anymore. So I'm going to clear the screen and it'll actually get rid of all that top display. There we go. So now we got our screen back. Okay. You can also kill something. So if I do a sleep 60, I'm going to throw that in the background here. Okay. I do a PS. You see that sleep command's running. I also have the process ID here. I can do a kill. I can do it by the process ID 416. And then you see it kills that command, okay? So we can kill commands based off their process ID. Okay. I can also do a man of different commands. So I can do a man, let's say kill command. It's going to display a manual page for me and just give me as much info as I would like on these commands. Examples, different flags for it, things like that. And examples is typically how you're going to look at these man pages. You want to see how it's used, okay? Something important to know, guys, is in these text files, if you do a / and then type in something, that's how you search for different things. So if you look at the bottom of my screen here, I have a / and then I can type in examples, oops, and hit enter, and it's going to search through this document and find everything that says examples here, okay, which it shows here, it highlighted examples, all right? So that's how you can search in these documents without having to actually go line by line finding what you're looking for. Now to get out of this, we just hit Q, and it takes us back out of it, okay? Next one we have is cat. I'm going to clear my screen first. I'm going to do an ls, and I'm going to cat one of these files. So I can do cat test, and it doesn't give me anything because nothing's actually in that file. I can also do, let's do that sun.txt. Oh, that one's empty too. I wonder if any of these have stuff in them. Let's try info.txt. Nope, they're all empty. Okay. But that cat file just displays info in files, okay? Oh, we did have a desktop here, guys. That's why it actually tried to, or sent something to desktop, lowercase desktop. So cat is how you would look at info in files. We have vim, so vim. And actually, I'm going to put some text in these files so we can see cat work. So let's go to sun.txt. So when I do vim here, and I give the file name, it'll take me to an editor. Okay, and inside this editor, if I want to add text, I hit I for insert. Okay, then I can start writing whatever I want here. Okay, so I'm just going to put cat this text. And then to get out of this insert mode, I have to escape. Now I'm in command mode, and I have to hit right or WQ for right quit to save that info. So now when I do cat sun.txt, we'll see that it has that text in there. Cat this text. Well, should have been text. I misspelled it. That's a typo, but you get the idea. All right, so last one we're going to look here on this slide is that chmod. Okay. So before I do that, I'm going to do a LL for long listing. Okay. We see all these different permissions here on these files, right? Okay. So let's look at just one file here. We're going to look at the sun.txt file. Okay. We see these permissions here. So if I want to change permissions on that, I would do chmod. Actually, let me clear my screen here. I'm going to do something kind of tricky. We're not going to talk about what I'm doing right now, but it's just to ll sun.txt, just so we can kind of compare here. Okay, so we see the permissions on sun.txt. Okay, so if I want to change permissions on that, I can do chmod, I can do 777, I can do numeric form, or I can actually do all plus read write execute. Okay, to actually change permissions on that sun.txt, I'm going to do a 444. Now do ll grep. So now we see the permissions changed, right? So chmod changes the permissions on files, and we can do it in numeric form, or we can do it in the actual read write execute way. Okay. Let's head back to our PowerPoint. We got some more commands to look at here. We have head. This is how you view the first n lines of data, so you can actually give it a number to display. We have tail, which will view the last n lines of data, so you can give it a number display to display a certain amount.
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
On a endpoint or inlines. Sort, which will organize the data into order. NL, or a number of lines, which will print line numbers before data. WC, word count, print a count of lines, words, and characters. Cut, which will cut the data into fields and only display the specified fields. Sed, which will do a search and replace on data. Unique, which will remove duplicate lines. And TAC, TAC, which will print the data in reverse order, okay? And guys, see how this is TAC? That might look a little weird, but if we go back to our previous slide here, we have cat, okay? So cat displays the order, or displays the contents in a file. This is just cat backwards, hence in reverse order. It's just displaying the content in reverse order, okay? So let's look at some of these. I won't be able to show you all of them, but I'll show you some of these. So let's do head first. So we put some text in that sun.txt file. Let me put some more lines in that file just so I can kind of show you what's going on here. So I'm gonna do oops. Actually, let me go ahead and go to a privileged user here just to make things easier. There we go. Then, I'm not gonna. Okay, so we're gonna make a new file here. It's gonna be test.txt. Okay, I'm gonna vim test.txt. All right, I'm gonna put some lines in here. Line 1, line 2, line 3, line 4, and line 5. I'm gonna exit or escape, right, quit. Okay. So now I'm going to do head on that file, head-in3, okay, test.txt. You see, just displays the first 3 lines of that file, right? Okay. I can do the same with tail. I can do tail-in3. It's going to display the last 3 lines of that file. There you go, line 3, 4, 5. So it's the last 3, okay? Let me go ahead and clear my screen to get some space back here. We're going to do sort. I won't be able to do that right now, but sort just sorts. Let me do a -- help to show you some of the things with it. Now it's going to give you a lot of things you can do here with sort. Typically, in is going to be the most common thing you use with sort, and we can see that here, which is numerical sort, or compare according to string numerical value. I use that one pretty frequently, sort-in. Okay, let me clear my screen here. We have print the number lines before data. We have print a count of word lines, so word count. Okay, so we can do that one. We'll do cat test.txt, and we're going to pipe that into word count. And there it gives you some numbers. It says there's 5 lines, 10 characters, letters, things like that. So it just gives you a word count. Okay. I won't be able to show you cut or sed or unique, but I can show you tac. So we can do tac test.txt. And then you see it gave it in reverse order, right? So it should be, the normal order is 1, 2, 3, 4, 5. It gave it to you backwards, right? 5 is the first line, 4 is the second, 3 is the third, 2 is actually the 4th line, and so on, okay? So it gave it to us in reverse order, okay? Let's head back to our PowerPoint here. Go to our next slide, which is going to be talking about command line editing. So the terminal holds a history of all commands used in the current session or instance of the terminal. Okay, you can look back and forth in the history using the up and down arrow keys, which is very helpful, guys, especially if you don't want to keep typing out long commands. Similarly, you can move your cursor back and forth in your current line using the left and right arrow keys. So if your cursor is overlapping a character, typing will put the new character immediately before the overlapped one. So let's look at this real quick. So if I press up on my arrow keys, it goes to the last command I did, right? If I press down, it'll go to my current command, which is nothing, okay? If I hit left on my cursor, or my arrow pads, see it starts moving left on the line. If I hit right, it starts moving right on the line. Now if I were to type a letter right here, it's going to put it behind that T, okay? So it actually puts the letter behind the cursor. So if I move one right now, it puts the letter behind and after the T, okay? Let's move on to our next slide here in our PowerPoint. We're just going to be, oops. So we're still doing command line editing, but here's kind of a graph of what those do. So up arrow recalls previous command, down recalls the next command, left will move the cursor left, right will move the cursor right. If we put or click Control A or home, it moves the cursor to the back of the line. If we do Control E or N, it moves the cursor to the end of the line. That's also really helpful, guys. So if I have a line here and it just has a ton of stuff on it, I don't want to have to try and arrow all the way back to the beginning of the line, right? So I can hit Control A and it takes me to the beginning of the line. Or I can do Control E on my keyboard and it takes me to the end of the line. Super helpful, okay? Saves you a lot of time by not having to actually arrow back and forth on that line. So let's look at how to interact with the file system. So you've seen me do this a couple of times now. This is the ls command. So it'll list the files and directories stored in the current directory you use, the ls command, okay? So the ls command supports the -l option, which gives you more information about the files. Typically, if you're going to do a -l, it's because you want to see the permissions of the files, or maybe you want to see how big the file is, okay? So I'll show you that again. So I've been doing ls, okay, which shows the files, or you can do, let me clear my screen real quick. So ls, or I can do ls-l, which shows all the files and the permissions. ll is a shorthand version of ls-l, okay? It does a long listing of stuff. Notice this, though, also displays the hidden files that we have here, okay? So ls-a shows hidden files. So if we do ls-la, ls-la is the same thing as ll, okay? Let me clear my screen. Let's head back to our PowerPoint. So we can also use meta characters, which are very useful in the command line. Okay, so meta characters have a special meaning in Unix. So for example, the star or splat and question mark are meta characters. So we see here we have ls ch star .doc, and this is going to display all the files, the name of which start with ch and end with .doc. Okay, depending where I put this star dictates how it'll be used. Okay, this star is here. Let's go to a VirtualBox here. So if I do a ls star test, it's gonna say, hey, show me everything that ends with test. Okay, if I put that star at the end of test here, it's gonna say, hey, show me everything that starts with test. Okay, so where we put that star dictates how it's used. Okay, since we put that other one in the middle, this is again saying, show me everything that starts with test and ends with test. Okay, so it just depends where you put that star, how it's used. Okay. So let's talk about how to create files. So you actually did see me use the touch command to create an empty file with a given name. Okay, so if I do touch file name, a file name with that name, or with the name file name is created. Okay, if a file with that name already exists, touch simply updates it with the last modified time. So a file name already existed, and I do touch file name again, it's just going to modify the last time that file was edited. Okay, we can use the Vim editor to actually edit text or files on the Unix system. Okay, you simply just need to give it a path as the first argument, and we're going to discuss Vim later in detail. Okay, now Vim 2 will just go ahead and create files. So let's say we do a Vim and we say the file we want to create. If the file doesn't exist, it's going to go ahead and create that file for us, open it, and we can start editing it. There are other Linux commands that create the file if it does not exist. For instance, if we try adding a text to a new file that does not exist with nano command, then it will perform two tasks. A, it will create the text file, and B, it will add text to it. Okay, just like I just said with Vim, if the file doesn't already exist, it's going to open that file for you, create it, and you can start editing it. We can also create multiple files at the same time too in Linux, which is helpful. So to copy a file, as we talked about earlier, you use the cp command. So you do cp, the file you want to copy, and where you want to copy it to. Okay, so here's an example. We do copy file name, copy file, and this will copy the file name to the destination copy file. Okay. Now, keep in mind we didn't give a full path here, so it's just going to assume that this is going to be used in our current directory here. Okay. So this is the same file as this still, just with the new name, and it's in the current directory. So we talked about cat earlier. So in the below example, the contents of Etsy password are displayed using cat. Now, we also talked about head and tail. So if there's too much info and you just want to see like just the first few lines of a file, we can use head, or maybe you want to see just the last few lines of a file, we can use tail. And as I mentioned earlier, move is how you actually rename files. Okay? So the syntax for move is move, the file you're moving or the file you want to rename, and then where you're moving it to or the new file name. So for example, we have move, file name, new file. Okay? So this is going to move the file name, and it's going to rename it new file in the current directory. Okay? So we also have a few ways we can control the terminal. We have Control C, Control Z, and Control D. Control C is the interrupt signal, and this causes the program to abort, but may simply stop some programs. Z is the suspend signal, and again, this will cause the program to abort, but it also may simply stop until they get a signal to resume, like say continue. And then we have Control D, or end of file character, which is used for when a program wants a full file for input, but you need to type it in, or intend to type it in. So I will show you that real quick. So if I run that sleep 60 command again, notice I don't actually have control of the terminal here. Okay, so if I do Control C, it's going to end that command, and now I do actually have control of the terminal again. Okay, let me clear my screen. If I do that again and hit Control Z, you can see here I don't have control of the terminal. I can't actually do anything. Control Z actually stopped that command. So remember, Control Z is signal stop, and it even tells you here sleep 60 was stopped, and now I have control of my terminal again, right? So those are helpful if your system's locked up, or maybe you need a job to stop running and you want control back of your terminal. So in summary, guys, we learned about basic user commands, logging in and logging out, terminal emulators, navigating file system, viewing and copying files, and how to manipulate the terminal. Next session, we're going to go over input and output redirection of pipes, command separation and grouping, background execution, file name expansion, shell variables, command substitution, quoting and escaping meta characters, fish shell features, command execution, and startup files. Guys, if you need extra help with this stuff, go ahead and follow these links. We have weekly and monthly plans available for private tutoring sessions for system administrator management, as well as Linux and Bash scripting. Thank you so much, guys. This concludes session 1. Looking forward to seeing you in session 2. What's up, guys? Welcome to session 2 of Introduction to Linux Bash Scripting. As always, I am your instructor, Kevin Downs. Today, we're going to be talking about Introduction to Linux Bash Scripting 2, and we're going to be going over shells, pipes, the fish shell, and more, okay? So last session, we went over basic user commands, logging in and logging out, command line editing, navigating the file system, viewing and copying files, and controlling the terminal. Today, we're going to be going over input and output redirection in pipes, command separation and grouping, background extinction, file name expansion, shell variables, command substitution, quoting and escaping meta characters, fish shell features, command execution, and startup files. Let's get started with input and output redirections. So most Unix system commands take input from your terminal and send the resulting output back to the terminal. So this is known as standard input and standard output. A command normally reads its input from the standard input, which happens to be your terminal by default. Similarly, a command normally writes its output to the standard output, which is again your terminal by default. So output redirection, the output from a command normally intended for standard output, can be easily diverted to a file instead. This capability is known as output redirection. So at the notation greater than sign, file is appended to any.
Thanks for watching. Please like and share this video.
Command that normally writes its output to standard output, the output of the command will be written to the file instead of your terminal. So here we can kind of see that. So we have the following example. We have the who command, and real quick, let me actually show you what the who command does. So who, oops, let me log in. So who normally displays this, okay? So if we go back to our PowerPoint here, that standard out of the who command is going to get redirected into the file users. So when we run this, notice that no output appears at the terminal, and this is because the output has been redirected from the default standard output device, the terminal, into the specified file. Let's actually go ahead and do that. So who. Now real quick, when we run ls, we see the only file that exists here is test.txt. So who, I'm going to redirect that to users. Now we see because the users file didn't actually exist, it created that file, right? And if I cat that file, you see it has that output, right? So the output from the who command got redirected to this file, users, and we can see that here. Here's the output of that. So that can be handy, as you can see. A lot of uses for that. Oops. So if a command has its output redirected to a file, and the file already contains some data, that data will be lost. Know that, guys. If you redirect output from a command to a file, or from a file to another file, using the single greater than sign, that data will be lost. So consider the following example. We have echo line 1, and we redirect that to users. Then we cat users. We see we have line 1. Okay. So I'll show you that real quick. Right now, cat users, we have that. So if I do echo line 1, and I redirect that to users, so I have cat users, and we still have that same output. Oops, I have a typo here. So I do echo. There we go. Now I spelled it right. Echo line 1. I use the greater than sign to redirect that to users. And now I cat users. Now it just says line 1. So it overrid the info in that file. Okay. Let's go back to our PowerPoint. So to save ourselves from doing that, what we can do is the greater than operator to append the output. Okay, so we look at our example here. We can do echo line 2, append to users. Then when we cat users, we have line 1 and line 2. I'll show you that. Echo line 2 and append greater than to users. Now when I cat users, we see both lines in there, so put it at the end of this file, right? So also very useful. Let's move on to our next slide there. So as the greater than character is used for output redirection, the less than character is used to redirect the input of a command. So upon execution, we will receive the following output. You can count the number of lines in the file by redirecting standard input of the word count command from file users. So we can actually go the other way. We can say send the info from users into the word count command. And it'll give you the count of that, okay? So we can actually flip the way those signs are redirecting stuff. And guys, keep in mind that input and output stuff is going to be covered much more in depth in our intermediate Linux admin course, okay? So we're just briefly going over it here. So we have a document called here. So a here document is used to redirect the input into an interactive shell script or program. The general form for a here document is, we see we have the command, 2 less than signs, and a delimiter. Okay, so delimiter is sent into command, and we have that there. So here the shell interprets the less than operator as an instruction to read input until it finds a line containing the specified delimiter. Okay, and guys, a delimiter could be like a colon, exclamation point. Okay, so it's just going through that file and looking for that specific delimiter that you specified. So all the input lines up to the line containing the delimiter are then fed into the standard input of the command. Okay. The delimiter tells the shell that the here document has completed. Without it, the shell continues to read the input forever. The delimiter must be a single word that does not contain spaces or tabs. So let's go over pipes and filters here. So in this section, we will discuss briefly about pipes and filters in Unix. And then again, guys, pipes and filters will be discussed more in depth in the next course, Intermediate Sysadmin, okay? So you can connect two commands together so that the output from one program becomes the input of the next program. Two or more commands connected in this way form a pipe. To make a pipe, put a vertical bar, and that's located just above your Enter key, or should be anyways, on the command line between two commands. When a program takes its input from another program, it performs some operation on that input and writes a result to a standard output. It is referred to as a filter. So the grep command is what's commonly used with these pipes, guys. So the grep command searches a file or files for lines that have a certain pattern. And the syntax for grep is grep, the pattern you're looking for, and then the file. So guys, the name grep comes from the ed file editor, which is Unix line editor. It stands for command grep, which means globally search for a regular expression and print all lines containing it. Global regular expression print. Okay? That's where grep comes from, guys. So the simplest use of grep is to look for a pattern consisting of a single word. It can be used in a pipe so that only those lines of the input files containing a given string are sent to the standard output. If you don't give grep a file name to read, it reads its standard input. That's the way all filtered programs work. So we cover more examples of grep later in this course. Okay. But here's some examples. So we do an ls-l and we grep for August. So when we do that, it's going to list all files that have a modified date of August, which we see here. Okay. There are also various options which we can use along with the grep command. We can do -v, which prints all lines that do not match pattern. -n, which prints the matched line and its line number. That can be very helpful. And -i, which prints only the names of files with the matching lines, letter I, or L. Sorry, -L. Okay, I'll show you that very quickly. So if I do an LL, I see all these different files here. Let's do just July here, just this July line. So I can do LL grep July. Okay. So you guys see what happened here is I did the full word July, and this only has JUL. So if I want that to work, I do grep JUL. And let's see if it actually do it lowercase. It won't. And I did that on purpose because I wanted to show you everything in Linux is case sensitive, right? Let me clear my screen so we have some space back. So LL. So I have to do LL grep JUL, just like it's spelled. And then it actually finds it, right? Because that's how it's actually spelled. Okay? I'll show you one more helpful thing here with grep, and that is -i, which means case insensitive. So just give me everything with the letters JUL in it. And there you go. Now it will actually show me JUL. Okay, because I did -i, case insensitive. That's very handy. If you can't, or you aren't sure how something's spelled, you want to throw that -i on there, okay? So the sort command arranges lines of text alphabetically or numerically. The following example sorts the lines in the food file. So we do sort food. And you can see here this is in alphabetical order. Afghani, Bangkok, Big, Isle, okay? Mandalay, Sushi, Sweet, Tio, okay? So this is the contents of that food file. It may not necessarily be in this order, but since we use sort, it is sorting it by alphabetical order based off the first letter, okay? So more than two commands may be linked up into a pipe. So taking a previous pipe example using grep, we can further sort the files modified in August by the order of size. So the following pipe consists of the commands ls, grep, and sort. So we do an ls-l, and then we grep August, so it's going to list all the files with August in there. we're going to sort it with a +4n. So that pipe sorts all files in your directory modified in August by order of size and prints them on the terminal screen, okay? So the sort option, +4n, skips 4 fields. And fields are separated by blanks, and then sorts the lines in numeric order. Okay? So we did an ls-l and sent that into grep, which searched for August, and it sent that into sort, and it sorted it based off the input of these two, okay? So here's some more pipe examples. We can list all files and pipe that into more. And that way we can scroll up and down, okay? We can also do a ls-al, which is all and long listing. And grep that and look for a list of all subdirectories in the current directory. Excuse me. We can also use head and tail to print lines in a particular range in a file. So we can cat the file sample2.txt, pipe that to head to give us the first 7 lines, and then pipe that to tail to give us the last 5 lines of those 7 lines we just did, okay? Here's some more examples. So this ps and wc command pipeline gives you an idea of how many processes are currently running on your system. So you can do ps aux, which is going to list all the processes running on our system. We're going to pipe that to word count, and it's going to give us a line, or it's going to, give us back the number of lines on that file. So that could tell us how many processes are running, because it'll tell us how many lines there are. We can also use cat, grep, t, and wc command to read the particular entry from user and store in a file and print line count. So we cat the file result.txt. We grep the phrase rajatx. We pipe that to t file2.txt. We give it a word count. Okay? So it's storing the input from this into the file2.txt. That's going to give us a word count. Okay? So a lot to do there, guys, with pipes and filters. Again, we're just scratching the surface on that. We're going to cover that more in depth later in our courses, okay? We're going to go ahead and talk about command separation and grouping. So Bash provides 2 ways to group all a list of commands to be executed as a unit. So placing a list of commands between parentheses causes a subshell environment to be created. And each of these commands is listed to be executed in the subshell. So we have an example of some commands. We have add user, user delete, add group, and delete group. So add user adds a user to the system. User delete deletes the user account and related files. Add group adds a group to the system. And delete group removes a group from the system. Background execution. So in Linux terminology and in Unix in general, a background process is a process that is started from shell or terminal and then runs independently, so in the background. When a background process has been launched from a terminal session, the same terminal will be immediately available to execute other commands. In contrast, a foreground process takes control of the terminal when launched, preventing any other command to run till it has finished. So as an example, when we run yes example1 and we redirect that to dev null, the process yes example1 being redirected to dev null is running in foreground and it is taking the control of the terminal entirely. The only way to get out of this is to hit Control Z and terminate the process. Guys, I showed this to you in our last session. I'll show it again. When I run that sleep command, let me clear my screen. So when I run sleep 60, you see, I don't have control of my terminal here, right? No matter what I type in, it's not going to let me do it. So I have to hit Control Z, and it frees up that process. Now, if I do sleep 60, and I use an ampersand sign to throw that process in the background, see, it tells you the process or the job has been created. Now, I have free reign on the terminal. It can actually start doing stuff while that command is running. Okay. So before, that process was running in the foreground. Now, when it's running in the background, I have control of my terminal. Okay. Is that, hopefully that makes sense. So you don't want to always.
Thanks for watching. Feel free to add your questions as comments down below.
Run stuff in the foreground. Sometimes it's good to run stuff in the background so you can keep doing things. So we're going to look at file name expansion. So another way to save time in your commands is to use special characters to abbreviate file names. You can specify many files at once by using these characters. This feature of the shell is sometimes called globbing. So MS-DOS provides a few crude features of this type. You can use a question mark to mean any character and an asterisk to mean any string of characters. Unix provides these wildcards too, but in a more robust and rigorous way. So we have some examples here. So let's say you have a directory containing the following C source files. We do ls. This is kind of hard to read here, guys, but we see we have this C file, this one, and this one, okay? So to list the three files containing the digits in the names, we could enter ls, we see inventory, and then we put the little question mark in the middle of it, and then j.c. And it's going to list all the ones that have 1, 2, and 3 here, right? Okay, just like we saw up here, 1, 2, 3. It lists these 3 here, but doesn't list these 2 because they didn't have numbers in the middle, okay? So the shell's looking for a single character to replace the question mark. Thus it displayed 1, 2, and 3, but not the ones without the numbers in the middle, right? Alright, now we're moving on to shell variables. So variables can be created either at the shell or in shell scripts. Any variable created within a shell script is lost when the script stops executing. A variable created at the prompt, however, will remain in existence until the shell is terminated. And we see that here below, guys. So on our terminal here, we can do a my var, or my variable, equals 999. So we're setting 999 equal to this variable name here. So when we echo my var, and variables are designated by a $, it'll say 999 because we set that variable equal to that, okay? However, there are some built-in variables into our shell, such as user, okay? And there's also home and some other ones. Let me show that to you. So I do echo $, user. It tells me that root is user, okay? There's also home, which tells me my home directory, okay? Echo $, I think shell is one. Yeah, and it tells you the shell you're using. So there's some built-in variables. Or if we use the example my var equals 999, and then I echo $, my var, so variables are designated by $, then we see that that variable exists. Now I can't just do a $, anything, right? I can't just type in gibberish, right? Because that's not a variable that's been declared, right? So we have to set the variable values. And we see that here as well. So we're kind of playing with the echo command here and how variables work. So we remember everything's case sensitive in Linux. So when we try to do the user variable in lowercase, echo only shows RAM but doesn't give the variable because that's not how you spell user correctly. Okay. And I showed you that shell variable, so it's going to say echo. This is the shell variable in Datasoft. And the shell variable was bin bash, just like I showed you. So it says this is the bin bash Datasoft. Okay. We can even use two variables on one line. So this is the shell variable on computer hostname variable. And it's going to repeat this is the bin bash on computer Datasoft Linux. So echo these words, and then it filled in the variables. Okay. And again, this one isn't going to work right because this isn't spelled correctly. That's not the right variable. Echo the user ID of user variable is user ID variable. Well, it's going to do some of it. It's going to say the user ID of, this isn't right, so it doesn't display it, is 1000. Okay. And then I showed you the home variable one. So my home directory is home. My home directory is home datasoft. Okay. So we're going to talk about command substitution here. So command substitution is the mechanism by which the shell performs a given set of commands and then substitutes their output in the place of the commands. So example of this here. Here, the printing variable of the variable is substituted by its value. At the same time, the \n is substituted by new line. So \n says new line. That's a new line character. So we have a equals 10. And then when we echo -e, value of a is variable a and a new line. So value of a is 10. Okay? So command substitution is generally used to assign the output of a command to a variable. Each of the following examples demonstrates a command substitution. So we actually set date equal to the date command. Okay. So we could echo date is and date command, and it would actually display the output of the date command. Okay. We can set the user's variable equal to the output of the who command piped into the word count command. And so when we echo logged in users are users, it's going to display the output of that, okay? And we have the up command, or up variable is set equal to the date and the uptime command. So guys, this little semicolon here, what this means is it means do this command, and on a new line, run this command, okay? So this isn't joining these two commands, it's just running them separately, but without having to do a new line, okay? Let me do echo uptime is up variable. Let me show you these. So we should know, so date command shows, let me clear my screen. So date command shows the date. So when I put date is equal to $, date, okay, now echo date is $date. There you go, it says date is, and it's the output of this date command, okay? So we're actually assigning a variable the output of a command. Same with the users one, we can do who. Remember, who gives you the users. Okay? So if I do users equals quotation mark $, parentheses, who, I'm piping that to word count -L, I'm closing the parentheses, quotation mark, and I do echo logged, logged in users are, I do the variable users, says logged in users are 1. Okay. And actually I need to okay, so it's giving me the number of logged in users here based off of how many lines there are. There's only one, so just give me the one user. I'm going to show you the date command again, and then uptime command. So date shows the date, uptime shows how long your system's been on, how many users, the load on the CPU, and how long it's been running, okay? So if I do up equals, quotation mark, $, parentheses, date, semicolon, uptime, parentheses, quotation mark, and then I say echo uptime is variable up. There you go. It combines those two outputs here. It says uptime is the date. Here's that. Guys, let me show you what that semicolon does. So if I do date semicolon uptime, there you go. See, it's running these commands separately. So it runs date first, and then it runs uptime. This is no different than me running date and then uptime. Okay? That's all the semicolon's doing. So that way I don't have to type these on two separate lines. I can just type it on one line, and it runs one after the other is completed. Okay? Let's head back to our PowerPoint. So we're going to talk about quoting and escaping meta characters here. So there are three options to avoid shell interpretation of meta characters. We can do it with a backslash, single quotes around a string, or double quotes. So you guys, single and double quotes protect each other, okay? So it interprets them if those quotes are around it. So, for example, if we have echo hi intro to Unix class, and we have single quotes outside of all of it, quotation, double quotes on intro to Unix, echo would actually spit out hi intro to Unix class with the double quotes around intro to Unix, okay? Similarly, if I do double quotation mark, hi, single quotes, intro to Unix class, and end it with a double quote, it will spit out hi intro to Unix class with the single quotes, okay? And here we look at that escape character. We have echo, quotation mark, backslash, 9800, quotation mark. So instead of interpreting this 9800 as a variable name, it's just actually going to echo this $sign, okay? Because this backslash character is saying, hey, this next character, don't interpret it as anything, okay? So that's how you would get out of kind of having them interpreted as specific commands or, you know, variable names. So up next, we're going to be talking about fish shell features. All right, guys, let's go ahead and talk about fish shell features. So fish shell is another shell similar to bin and bash, except it has a lot of extended features to it. So fish shell is a smart and user-friendly command line shell for Linux, Mac OS, and the rest of the family. Fish is a more modern shell with the goal of being more interactive and more user-friendly than older shells, such as bin bash. Unlike its competition, Fish is not based on the Bourne shell or the C shell, but attempts to blaze its own path. So Fish shell comes with some nice features such as auto suggestions as you type, syntax highlighting with extensive error checking, searchable command history, 256 terminal colors, advanced tab completion, web-based configuration. A special help command gives access to all Fish documentation in the user's web browser. Error messages designed to actually tell the user what went wrong and what can be done about it. Universal variable supports the X clipboard. You can change Fish settings by editing the file home config fish config.fish file. Man page completions fully scriptable with syntax that is simple, clean, and consistent, and features work out of the box without any configuration. Guys, this is all nice and great. However, typically you're going to be using the bash shell. So I will show you some examples of how Fish shell works, but bash is really what you're going to be using for the most part. Eventually things may shift over to this Fish shell, but that's going to take time. You're going to realize that companies are slow to upgrade, okay? And they stick with things as long as they can while they're still supported and working, and once it runs out of support and it has to be upgraded, that's when they do it. So go ahead and get familiar with the bash shell, and don't worry too much about Fish shell right now. So Fish shell runs just like the other shells. So for example here, it has the same command, echo and hello world, and it'll display hello world. We can do make directory my/files, okay, and we can copy just like in the other one, home/some, and then my files, okay. And we can do an ls of my files, and it'll show that file in there. We can also list JPEG files using the same meta characters we talked about for ls star.jpg, and it'll list all the files that ends in jpeg.jpg. We can also put those stars in between, so it'll list all files that start with an L.
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
End with the .p and start with the .p. Okay, just like this. And we can pipe just like we did before. We can say echo hello world and give us a word count. One line, right? 2 words, 12 characters. So fish shell is nice, and it works just the same as much as the other shells do. Alright guys, let's go ahead and finish this session out with command execution and startup files. So command execution, we have an exec command in Linux, and it's used to execute a command from the bash itself. This command does not create a new process, it just replaces the bash with the command to be executed. So if the exec command is successful, it does not return to the calling process. So here we see we have a bash command, we do an exec ls, and it just spits out the ls command, okay? Exec isn't used too often, guys, but I do want you to be familiar with it. We also have startup files. So Linux, again, is a multi-user time-sharing system, implying that more than one user can log in and use the system. System administrators have the task of managing various aspects of how different users can operate a system in terms of installing, updating, and removing software and programs they can run, as well as files they can view and edit and so on, okay? So this is kind of controlled through startup files. So when a system starts up, all these startup files run, and in those startup files contain some stuff like controlling how users can actually use the CPU, you know, kind of sets resource limits for them, tells them what commands they can and can't use through sudo files, okay, as well as what directories they can and can't access, and all this is done at startup before they log on, okay? So that's what startup files are. So in summary, guys, we went over I/O and redirection input, or redirection and pipes, so input, output, redirection and pipes, command separation and grouping, background extension, or background execution, file name expansion, shell variables, command substitution, quoting and escaping meta characters, fish shell features, command execution, and startup files. Next session, we got a lot to cover. We're going to go over shell script features and capabilities, creating and running a script, working with variables, environmental variables, working with data types such as formatting, base conversion, and setting special attributes, input and output techniques, conditional constructs as if then and else if, looping constructs such as for, while, and until, as well as basic operators. Guys, I highly recommend following these links to get some private tutoring sessions for system administrator management. There are weekly and monthly plans available, and there are also private sessions available for Linux and Bash scripting. Thank you so much for joining me in session 2 here, guys. This has been a course and class by coding-bootcamps.com. Looking forward to seeing you on session 3. Moving on to example 6 here, we're going to match lines of a certain length. Okay, so to match lines of a particular length, we use that number of the period character between the caret symbol and the dollar sign. Okay, so we're going to use 3 different meta characters here. So for example, to match all lines that are 2 characters or columns wide, we use caret, period, period, dollar sign as a regex to search for. So we're going to do that now. On the book text file, we're going to use grep, caret, 3 periods, and a dollar sign. Okay, so grep, single quote, caret, period, 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 dollar sign, single quote, book. Okay, so this is giving us all characters that are all lines that are exactly 3 characters wide or long. In this case, we only have 1, and that's pro, right? So let's go back to our homework. Now, we're going to look at some lines that are a little bit longer. Okay, but there's a more useful and simple way to do it. Okay, so for longer lines, it's more useful to use the different constructs. So in this case, we would do single quote, caret, period, backslash, the number, so curly brace, the number of lines or characters we want to match. I'm sorry, not the number of lines, but how wide we want it to be. And then another backslash, curly brace, dollar sign, single quote, okay? Guys, that's actually kind of a lot to remember. So we know the caret symbol means the beginning of a line, and we know the period means match the character spot, okay? but these curly braces are probably new to us, and we know that this $ means match the end of it. You're just going to have to remember this little construct here, right? It's a little too much to think about what each individual character means. You're just going to have to remember that this is how you set it up if you want to match something that's a certain length or width, okay? So we're going to look at how to do that with 12 characters here. So we're going to find lines that are 12 characters wide in the file book. So we do grep, single quote, caret, period, \, 12 characters wide, \, oop, and I forgot our curly brace here. Curly brace in front of that first after that first \. There we go. And then we close out that curly brace after the second $, single quote, book. And there you go. We have exactly one line that's 12 characters long. Now, you may be looking at this and counting and thinking, well, that's not 12. But remember, every single letter, space, and even this apostrophe here counts as a character, right? So we have 1, 2, 3, counting the apostrophe, 4, 5, counting the space, 6, 7, 8, 9, 10, counting the space again, and then 11, 12. So it actually is 12 characters long because the spaces and apostrophe count. Okay. Now the end, the space after the O doesn't count as a space. That's actually the end of the line. There is technically no space after that. So we're going to look at one more way to do that, and that's actually looking at 22 characters wide, all right? So we're heading back to our virtual box here. I'm going to clear my screen real quick, get some space back. So we're going to do grep, space, single quote, caret, period, \, curly brace, 22 characters this time, \, curly brace, $, single quote on file book. So we have exactly one line in that file, and that is continue your learning. If we count that out, that is 22 characters long. So that's how you can search for certain lines that have a certain number of characters in them. What's up, guys? Welcome to session 3 of Introduction to Linux Bash Scripting. As always, I am your instructor, Kevin Downs. Let's go and get started here. So in our third session here, we're going to be going over shell programming. In our last session, we went over input, output, redirection, and pipes, command separation and grouping, background execution, file name expansion, shell variables, command substitution, quoting and escaping meta characters, fish shell features, command execution, and startup files. Today, we'll be going over shell script features and capabilities, creating and running a script, working with variables, environmental variables, working with data types such as formatting, base conversion, and setting special attributes, and input-output techniques, conditional constructs such as if-then and else-if, looping constructs such as for, while, until, and basic operators. Let's go and get started with some shell script features and capabilities. So in shell scripts, you can use wildcard substitution and file names, background processing, command aliasing, command history, file name substitution, input and output redirection, piping, and shell variable substitution. So the things we can do in bash and normal command line, we can also use in our scripts. So why use bash scripting? Well, it's good for orchestrating system startup shutdown tasks, automatically renaming collection of files, finding all duplicate MP3 files on a hard drive, or other duplicate files. It doesn't have to be MP3 files. Orchestrating a suite of tools for tracking a password database, or a suite of tools. Finding weasel words in your writing, okay? And guys, weasel words just means finding specific words in like your script or your files, okay? So that's just a phrase. Implementing a relational database out of text files, and simplifying configuration and reconfiguration of software. So in order to create and run a script, we'd have to open the terminal, go to the directory where you want to create your script, create a file with the .sh extension. And guys, this serves two purposes. One, when we put .sh at the end of the file, it tells everyone else as well as yourself that this is a script file. And when we open an editor such as Vim, by using this extension, it actually opens up other features that are only available to a shell script, okay? So next we would write the script in a file using editors such as Vim. We would make the script executable with the command chmod plus x and then the script name. And then we would run the script using the / file name. Or, if this script is contained somewhere else besides our current directory, we would give the full path right here, okay? Not just /. / says, look in the current directory I'm in and run this, okay? So guys, take note in the last step, just as I mentioned, the path of the script is used, or the full path is used if the script is in another directory, okay? So an example of this, guys, I want to create a script called hello.sh, so I would do vim space hello.sh. I would put my hash playing at the beginning here, okay? And this hash playing, guys, tells the loader what interpreter to use, okay? We could do /bin, /kshell, /fishshell, or any other shells we'd like to use. This is always the first thing that's put in our shell scripts. This is called the hash pling, okay? So it's # or hashtag and then exclamation point and then the shell you're going to use, okay? And then here we have a comment, and comments are not interpreted by the interpreter. So when it sees this hashtag or #, it says, hey, don't interpret this line. We have another comment here, and we're going to say, hey, echo hello. And then once we're done with that, we'll do a right quit, and we'll do chmod plus x hello.sh to make the script executable, and then we'll execute the script. So let's talk about working with variables. This is a very important topic. So a variable is a character string to which we assign a value. The value assigned could be a number, it could be a text, it could be a file name, device, or any other type of data. So a variable is nothing more than a pointer to the actual data. The shell enables you to create, assign, and delete variables. The name of variables contain only letters, so A to Z or capital A to Z, numbers 0 to 9, or the underscore character. So by convention, Unix shell variables will have the names in uppercase. So those home and shell and user variables are always going to be uppercase. The following examples are valid variable names. So we have underscore ALI, token underscore A, var underscore 1, and bar underscore 2. These are all correct variable names. Here are some incorrect variable names. We have 2 underscore var, we have dash variable, we have var1 dash variable 2, and we have var underscore A exclamation point. So guys, these are not right. We can't use this exclamation point or this dash here, okay, the dash here. Alright, we can't use those things when we're doing those variables. So guys, the reason we can't use those in variable names is because these commands, such as exclamation point, star, dash, are characters that have a special meaning for this shell, right? So when it sees that, it's going to try and interpret those as the actual exclamation point or star, not a name of the file, okay? So guys, to access a value of a variable here, you would see we would say the variable. In this case, we have name. And then we would set it equal to the string XYZ. And then we would echo, and then variables always start with a $. And the variable name was name. And so it would spit out XYZ, right? So variables in Bash have a dual nature as both arrays and variables. So to set a variable, as we just saw, we would use the equal sign. Okay, so if we do foo equals 3, this sets foo to the number 3. But make sure, guys, that you don't put a space in between the equal sign and 3 here. So if we do that below here, so we have foo space equals space 3, this actually invokes the command foo with the arguments equals and 3. So it thinks foo is a command, and now because there's spaces here, it thinks that equal sign is an argument and the 3 is an argument, okay? So make sure when you set a variable, there are no spaces. If you want to use a space, you can dip into the expression sublanguage that exists inside double parentheses. So here we can do double parentheses, and we can do foo space equals 3, okay? And that will actually set foo to 3. Okay? And just as we've been seeing, to reference a value of a variable, you use a $, right? So when I do echo, and I want to echo the value of the variable foo, I have to put that $, there so it knows that this is a variable. We can also delete a variable or unset it. So if I say foo equals 42 and I echo foo, it's going to say 42. Well, I don't
Thanks for watching. Please like and share this video.
want that to equal 42 anymore, so I do unset is the command, space, and foo is the variable name. And now when I do echo foo, it's going to print nothing, right? Because I unset that variable. We can also set one variable equal to another. So here I can say foo equals the variable bar. And this will assign the value of the variable bar to foo. If you want to assign a value which contains spaces, be sure that you quote it, guys. So this is wrong here. We say foo equals x space y space z. Okay, this is actually going to set the foo variable equal to x, and it's going to actually try to execute y on z. Okay, the right way to do this is foo equals quotation mark x y z with spaces in between, and that will actually set the variable foo to x space y space z. And sometimes, guys, it's actually necessary to wrap a reference to a variable in braces, such as we see here. We see echo $. We have some curly braces. Okay. And then the variable foo. Okay. And that's important. We're going to see some examples here shortly about why that's important. So there are some special bash variables for grabbing arguments to scripts and functions. Okay. So echo 0 prints the script name. So variable 0. Variable 1 prints the first argument, 2 the second argument, all the way up until 9. So 3, well, third, fourth, etc. All the way up until 9. And then at 10, this actually prints the first argument followed by 0. So what we have to do, for these only, we have to actually cover it with these curly braces so that it prints the 10th argument, right? And then we have the $, hashtag, or £, which prints the number of arguments, okay, which we'll see later. So it is possible to write arithmetic expressions in bash, but you have to use some caution when you're doing this, guys. So we can use the command expr or expression, which prints the results of arithmetic expressions, but one must take caution, just as we said. So expression 3 plus 12 will print 15, but expression 3 times 12 will probably, not always, but probably crash, and it's going to try and expand to all files. So what we'd actually have to do is we have to do expression space 3, we have to do a backslash, and guys, this backslash is an escape character. This tells the command line, hey, whatever comes next, don't interpret as a command, okay? Take it as it is, all right? So in this case, it would be multiplies, and this will actually multiply 3 by 2, or 12 now, which would come out to 36. A much better way to do arithmetic, guys, is this double parentheses here, okay? It's a much more forgiving method, so we can do x equals 3 plus 12, and what's going to happen is it's going to assign 3 plus 12 to x, so we'll give the value 15 to x, and if we do echo variable x, it prints 15. Same with multiplying, 3 times 12, assign that to the variable x, we echo the variable x, and that would print 36. If you want the result of an arithmetic expression without assigning it, you can do the following format below, which is going to be $, double parentheses, and then the arithmetic inside. So this would print 15, this would print 36, okay? Let's talk about environmental variables. So environmental variables, or ENVs, basically define behavior of the environment. They can affect the process as ongoing or the programs that are executed in the environment. So let's talk about the scope of an environment variable. So scope of any variable is the region from which it can be accessed or over which it is defined. An environment variable in Linux can have global or local scope. So if it's a global variable, a global scoped in variable that is defined to a terminal can be accessed from anywhere in the particular environment which exists in the terminal. So that means it can be used in all kinds of scripts, programs, or processes running in the environment bound by the terminal. So here we see export and then the variable name and the value. So this is how we set a global variable. We have to use that export option, okay, or command. Or we can do set and then the variable name and the value of the variable. So export or set command both work for that. So guys, when I do this, this means that if any user logs on to the system and they have a variable, let's say it's named foo and it equals bar, any user on the system will have that variable foo with the value of bar in it, and they can use it in their scripts or their terminal, okay? On the contrary, local variables, so a locally scoped environment variable that is defined in a terminal cannot be accessed by any program or process running in the terminal. Can only be accessed by the terminal in which it is defined. And remember, we just saw how to do that. All the previous variables we saw were all the variable equals and then the value, and that's it, right? So local variables can be accessed only on the terminal that they were set in. Global variables can be accessed on any terminal by any user on the environment. So let's move on to data types. So data types used by a kernel are divided into three main classes. The first is standard C types such as integer, explicitly sized types such as U32, and types used for specific kernel objects such as PID_T. We're going to see when and how each of the three data type classes should be used. For example, there are typical problems you might run into when porting driver code from by86 to other platforms or when linked lists are exported by recent kernel headers. This is just an architecture type, guys. This is 86 type, okay? And before I move on, I just want you to know that we're going to briefly cover these data types, and the conversions of these numbers here aren't too important for what you're going to be doing right now. You just want to have some foundational knowledge for them, okay? So we're going to look at formatting here, okay? So map to java.lang.integer, the binary representation is a 4-byte integer with the sign bit flipped, okay? So we're looking at integers here, okay? So these are going to be integers. So possible values for an integer can be 0 all the way up to this huge number right here, right? And again, this is mapped to java.lang.integer. The binary representation is a 4-bit integer matching the HBase bytes to bytes method. The purpose of this type is to map existing HBase data that was serialized using this HBase utility method. If that is not the case, use the regular sign type instead, okay? An example of that is any unassigned integer, okay, which we just saw here. It can be any number between 0 all the way up to this huge number here. We also have the timestamp data type, okay? And the format is year, month, day, okay? Hour, minute, second, okay? And this is mapped to java.sql.timestamp with an internal representation of the number of nanos from the epoch. The binary representation is 12 bytes and 8-byte long. An 8-byte long for the epoch time plus a 4-byte integer for the nanos, okay? An example of here could be any timestamp we want, okay? So I could actually, I'll just type it here. I could say like 1970, oops, sorry guys. Get back to our slide here. Press the wrong button. So I could say, you know, like 1970, oops, did it again. Oh, I know why. My number lock's off. Sorry, guys. 1 second. There we go. There we go. 1970. That's the year. I could say like the month is 02, so February, and I could say 1st. I could say the 8th hour, 8 a.m. So 08, 32 minutes, and 47 seconds. All right, so that would be an acceptable timestamp, right? All right. All right, we can go ahead and talk about base conversion here, which is how to convert numeric bases within shell scripts. There are really 4 commonly used numeric bases to consider: binary, octal, decimal, and hexadecimal. So we used to work in base 10, so 10 equals 1 times 10 to the first plus 0, and 100 equals 1 times 10 to the 2 plus 0 times 10 to the 1 equal plus 0, okay? So you see we started at 2 and then 1 and we went down, okay? So that maps to other numeric bases. So 1010 base 2, our binary, is really 1 times 2 to the third plus 0 times 2 to the second plus 1 times 2 to the first plus 0, or 8 plus 0 plus 2 plus 0 equals 10, right? Octal is the same thing, so 33 base 8 converts to decimal as 3 times 8 to the first plus 3 equals 27. The long, complicated way to create a base conversion utility is therefore to disassemble every value given and apply to the transition shown. Then have an internal value that's a common base, probably base 10, and then have another routine that converts the common base to the desired output, which we kind of saw up here, right? That's the long way to do it. A much simpler way to do it is what we see here. So there's other ways to do this. For example, the BC command, which supports to users specifying both the input and output numeric base BC. The binary calculator. It is a bit tricky to work with as it's an old school units command, and the most common way to work with it is the BC program is to use echo to send it to the commands needed as demonstrated here. So we can do echo, quotation mark, I base equals 16, semicolon, O base equals 2, semicolon, FEF 33 D9, single quote, space, pipe, space, BC. And we hit enter, and it will give us the representation, okay? Guys, remember semicolon is just a way to type a command on the next line. This is no different than typing this command, hitting enter, typing this command, hitting enter, and then typing this command, okay? The semicolon is just creating a new command line, okay? So let's talk about setting special attributes. So variables and parameters are used by Korn shell to store values. Like other high-level programming languages, the Korn shell supports data types and arrays. Shell variable names can begin with an alphabetical A through Z or underscore character followed by one or more alphanumeric A through Z 0 through 9 underscore characters. Other variable names that contain only digits or special characters, such as exclamation point, at, pound or hashtag, percent, splat or star, question mark, dollar sign, are reserved for special parameters set directly by the Korn shell. So shell variables can have one or more attributes that specify the internal representation, access, or scope, or the way they are displayed. This concept is similar to a data type in other high-level programming languages, except that in Korn shell it is not restrictive. Variables can be set to integer type for faster arithmetic operations, read-only so that the value cannot be changed. Left-right, justified for formatting purposes, and more. To assign a value and or attribute to a Korn shell variable, use the following format with typeset command. So we do the command typeset space dash the attribute we want to do, and then the variable equals to the value we want to set. Okay. Let's go ahead and talk about input and output techniques. So the bash shell has 3 standard streams in input and output direction, which we've seen before. The first one is standard input, and the standard input stream is numbered as standard in 0, and the bash shell takes input from the standard in. So by default, the keyboard is used as input, okay, and we see that here. So we see less than sign, this is standard input, and this is going to overwrite any files we have. And then we have 2 less than signs, which is standard input, and it's going to append any info we have, okay? We also have standard output, or standard out, and the standard out stream is numbered as standard out 1, and the bash shell sends output to standard out. Output goes to the display. This is what we see when we hit enter on a command. So we have the greater than sign, which redirects standard output, and this overwrites again. And we have 2 greater than signs, which redirects standard output and appends it, okay? Last one we have here is standard error. The standard error stream is numbered as standard error 2. The bash shell sends error messages to the standard error. Error messages also go to the display. So to use this, we have to do the number 2 and then the greater sign, and that will redirect errors. Okay, this works just the same as the other 2. 1 greater than sign overwrites and 2 appends. Okay, so guys, this is similar to standard out, except this only works for errors. Okay, so if I were to do, let's say, a cd to a directory named fake, okay, and that directory doesn't exist, an error is going to come back to me. It's going to say, hey, that directory doesn't exist. So if I did a 2 greater than sign, it would actually redirect that error to wherever I would like it to go. Okay. However, if the directory did exist and I tried to redirect this, it wouldn't work because it's not an error. Okay. So following this, guys, we're going to go ahead and start talking about conditional, constructs. Let's go ahead and get into some of the constructs when we're doing shell script statements. Okay. So the first one is conditional constructs. So we're going to be there are total of 5 conditional statements which can be used in.
Thanks for watching. Feel free to add your questions as comments down below.
Bash programming. So the first one is going to be an if statement. The second will be an if-else statement. The third will be an if-else. Okay? So we kind of just keep going back and forth between the else and else if. The fourth is if, then, else, if, then, end. So nested ifs. Okay? So we could have like a if, then, else, and then underneath that, within that if statement, then we have a whole nother if-then statement. Okay? And then we have switch statements. So we're going to look at an if-then one here. So this block will be processed if specified condition is true. So if this expression, this block of code is true, then do this. And then end it, phi. Okay? So that's our first one here. Okay. Oops. Sorry guys, one second. There we go. Okay. So if this is true, then do this, and with phi. So an example of this would be echo hello. And we'd say if variable 1 is equal to awesome, then echo you are awesome. And then end it, and then we would echo bye. Okay. So if variable 1 is equal to awesome, then echo you are awesome. Next one we're going to look at is else and elif or else if. So to use multiple conditions in one if-else block, then elif keyword is used in the shell. If expression 1 is true, then it executes statement 1 and 2, and this process continues. If none of the conditions are true, then it processes the else part. Okay. So if expression 1 is true, then do statement 1 and statement 2. Okay. Else if expression 2 is true, then statement 2 and 3. If neither of these are true, else do statement 5. So, okay. So if this is true, then do these. Else if this is true, then do these two. If neither of these are true, else do this. End, phi. So remember, if statements are ended with fi, it's just if in reverse, phi. Easy way to remember that is finish. Okay. And next we're going to be looking at looping constructs. So a loop is a powerful programming tool that enables you to execute a set of commands repeatedly. In this session, we will examine the following types of loops available to shell programs. The while loop, okay, the for loop, break, and continue. Guys, the for loop is especially useful. It's one that I use very frequently when I have to do the same thing on multiple different servers. So shell loop types, you will use different loops based on the situation. For example, the while loop executes the given commands until the given condition remains true. The until loop executes until a given condition becomes true. So while happens while it's true, until happens until it's true. Okay? Once you have good programming practice, you will gain expertise and thereby start using appropriate loops based on the situation. So here's some example of shell loop types. I know this is kind of hard to see, but it says while command 1. It says this is loop 1, the outer loop. Do statement to be executed if command 1 is true. So while this is true, do this. And while command 2 is true, do this. And then you would finish it with done. So we finish while loops with the phrase done. Okay? And then you see this is nested inside of this while statement. So while this is true, do all of these things. We have separate, conditional ones here, like if this is true, I'll keep doing this. And when all of this is finished, then we're done, okay? So here's an example with actual code. So we have our hash playing, we have a equal to 0, we have the variable a equals 0. So while a is less than 10, do b equals the value of a. And while b is greater than 0, do echo the value of b, so the variable b. And we set b equal to variable b minus 1. Done. And then we echo a equals expression variable a plus 1. And done. Okay? So we have some shell loop types. The first one's the infinite loop. So all the loops have a limited life and they exit once the condition is false or true depending on the loop. A loop may continue forever if the required condition is not met. For this reason, such loops are called infinite loops. And guys, sometimes we do this on purpose and sometimes this actually does not happen on purpose and it's a bad thing. Sometimes we make loops that can't finish and we have what happens here, which is to get stuck in an infinite loop. And sometimes that's a bad thing. Other times, though, it's useful and we want it to happen. So here's an example, a simple one, that uses the while loop to display the numbers 0 to 9. So we have our hash playing, and we have this variable a equals 10. So until a is less than 10, do echo and variable a. We're set a equal to expression a plus 1. Done. Okay. This loop will continue forever because a is always greater than or equal to 10. And it's never less than 10. So this is never going to finish, right? Because it will never be less than 10. And this is an until loop. Remember, those go until it becomes true, and this will never be true. We also have ways to control loops. So we have the break statement. The break statement is used to terminate the execution of the entire loop after completing the execution of all the lines of code up to the break statement. So the syntax of that is the following. The following break statement is used to exit a loop. So we put the phrase break, and the break command also be used to exit from a nested loop using this format, break in. In which case here the n specifies the nth and closing loop to exit from. So I'm going to go back a couple of slides. And we saw here we have multiple loops here, so we could say break 2, and we'll say in this second nested loop is where we want it to break, right? Okay. So here we have an example of that. We have our hash playing, we have the variable a equal to 0. We have the while loop that says while variable a is less than 10, do echo variable a. And we have an if-then statement, so if variable a is equal to 5, then we put the break statement in and we end it. We say a equals expression variable a plus 1, done. So upon execution, we're going to receive the following result. So we'll have 0, 1, 2, 3, 4, 5. And we have the break. Okay, so this is our break statement here. It breaks when a is equal to 5. Okay, so the while loop's going until it's less than 10. But here we say, hey, when it gets to 5, go ahead and stop it, break it. And that's what happened. We got all the way to 5. And you see here, it actually started with 0, guys. So remember, 0 is a number. So it always starts with 0. We also have the continue statement, which is another loop control. And this is similar to break command, except that it causes the current iteration of the loop to exit rather than the entire loop. This statement is useful when an error has occurred, but you want to try to execute the next iteration of the loop, okay? So syntax is, we use the continue phrase, and like with the break statement, integer argument can be given to the continue command to skip commands from nested loops. Such as here, we have continue in, which will specify the loop you'd like to continue from. So we have an example of that here. We have a hash playing. We have a variable called nums, or nums, or numbers, which equals 1, 2, 3, 4, 5, 6, 7. So for numbers in nums, the variable nums, do, and this is a for loop, guys, so do variable q equals expression, variable number, %2, and this is a modulus sign, and we're going to go over all these signs later. So if variable q is equal to 0, then echo number is an even number. And we continue. Phi, or in, echo, found odd number, done. Okay. So here's what's going to happen from that. It's going to say found odd number, number is an even number, found odd number, number is an even number, found odd number, number is even number, and then it's going to finish, right? Okay. So it went through all those numbers for that for loop, and it finished at 7, okay? So here we're going to talk about the for loop. The for loop operates on a list of items, as we just saw, or repeats a set of commands for every item in a list. So the syntax for for loops is for variable in word 1, 2, etc., all the way to however many words you have, do, and the statement to be executed for every word. Okay, so for variable, and we execute that in these words here, and done. Here, variable is the name of variable, and word 1 to word n are sequences of characters separated by spaces. Each time the loop executes, the value of the variable is set to the next word in the list of words, word 1 to word n. Okay, so basically it takes this variable, executes it on this word, goes all the way through, and it starts over, does it on the second word, goes all the way through, starts over, third word, and so on. So here's an example that uses the for loop to span through the given list of numbers. So for variable in 0, 1, 2, 3, 4, all the way to 9, do echo variable. Okay? So upon execution, we receive the following result. So basically, it's setting variable equal to 0, to 1, to 2, to 3, all the way to 9, which we see here. Up next, we're going to be talking about basic operators. Let's go ahead and finish out our session today talking about basic operators. So we're going to discuss the following operators: arithmetic operators, relational operators, Boolean operators, and string operators. We're going to start with the arithmetic operators, and we're going to show you how to add two numbers here in this example. So we have value, which is the variable name value, equals expression 2 plus 2. When we do echo total value and then variable value, we would get the following. Total value is 4, because 2 plus 2 would equal 4. Okay. So here's a graph of some basic operators. So we have plus for addition, minus for subtraction, star or splat for multiplication, / for division. We have the percent sign for modulus. And guys, modulus is similar to division, except it divides the left-hand operand by the right-hand operand, and it returns the remainder. So we could do expression variable b modulus variable a. It's going to give 0. Okay. Assuming, let's just assume b is 1 and a is 1. So 1 divided by 1 is going to have equal 1 with 0 remainder, so 0. So it would actually just give you the value 0. We have equals, which assigns right operand to the left operand. Okay, so we could do like a equals variable b, which would assign the value of b into a. Then we have a double equal sign, okay, which compares two numbers. If both are the same, then it returns a true value. Okay. So we have an example of that. We say variable a is equal to variable b, which would return false. Okay. And then we have the exclamation point equal sign, which is not equal. So it compares two numbers. If both are different, then returns true. So that's kind of tricky, guys. It says if both are different, then return true. So it's saying if they are different, then it's a true statement. Whereas this one's saying if they are both the same, then return true. Okay. So variable a does not equal variable b. This is true, so it returns a true value. We also have relational operators. So Bourne shell supports the following relational operators that are specific to numeric values. These operations do not work for string values unless their values are numeric. For example, following operators will work to check a relation between 10 and 20, as well as in between 10 and 20, but not in between 10 and 20. Okay, so all that's saying, guys, is it's going to check the integer values 10 and 20, but not the string values ten and 20. Okay. So let's assume variable a holds 10 and variable b holds 20, and we're going to look at this. So saying dash eq or equals checks if the values of the two operands are equal. So if a is equal to b, it's not true, right? 10 is not equal to 20, so it's not true. We have ne, which stands for not equal, so it checks if the values of the two operands are equal or not. If the values are not equal, then the condition becomes true. So variable a is not equal to variable b. This is true. 10 is not equal to 20. We have gt or greater. This checks if the value of the left operand is greater than the value of the right operand. If yes, then it's true. So if variable A is greater than variable B, and this is not true, 10 is not greater than 20. Okay? And dash LT less than checks if the value of the left is less than the value of the right. So is variable A less than variable B?
Thanks for watching. Feel free to add your questions as comments down below.
Yes, so that's true. And then we have G, which stands for greater than or equal to. So this checks if the value of the left operand is greater than or equal to the value of the right operand. If yes, the condition becomes true. So is A greater than or equal to B? No. Okay, so it's not true. And then we have less than or equal to, which is the opposite of this. Checks if the values of the left is less than or equal to the value of the right. Is A less than or equal to B? Yes, so it's true. Oops, sorry guys. There we go. So we have some examples here. I'm not going to go through all these. I'm just going to kind of brush on a couple of these, and you can spend a little bit more time looking at them if you like. We have some examples here. So it's just as above, you know. So we had if A is equal to 10 and B is equal to 20. We have some examples here. So here's how we can use them in like if-then statements. So if variable A is equal to variable B, then echo variable B is equal to variable B. A to B, sorry. Okay. Else echo variable A is equal to variable B. A is not equal to B. Okay. So in this case, 10 is not equal to B. So instead of doing this first then, it's going to do else. So it's going to say A is not equal to B. Okay. And then it's going to end the statement. Okay. So you do that the same for all these guys. So I want you to actually go through these yourselves and determine what's going to happen on them based off of what we just read in this graph. Okay. So let's talk about Boolean operators. So the following Boolean operators are supported to the Bourne shell. Assume variable A holds 10 and variable B holds 20, just as before. So assuming that A holds 10 and B holds 20, then the operator exclamation point or bang, this is a local negation. This inverts a true condition into a false and vice versa. So not false is actually true, right? The opposite of false is true. We have dash O. This is the logical OR. So if one of the operands is true, then the condition becomes true. So if A is less than 20 or B is greater than 100, then it's true. Is A less than 20? Yes. Is B greater than 100? No. But A was true, so the whole statement's true. And then we have the logical AND. So if both the operators are true, then the condition becomes true otherwise. So is A less than 20 and is B less than or greater than 100? Well, A is less than, or 10 is less than 20, and is 20 greater than 100? No, so the whole statement's false. And here's some examples of that and how we can use them if-then statements. So again, A equals 10, B equals 20. So we can look at our first one here. So if variable A is not equal to B, then echo variable A is not equal to B, A is not equal to B. Else echo A is equal to B. So in this case, obviously 10 is not equal to 20, so it's going to echo that second statement there. And so on for the following examples, right? It's going to be the same for all these examples. We also have string operators. So the following string operators are supported by the Bourne shell. Let's assume variable A holds ABC and variable B holds EFG. Okay. Remember, guys, these are string operators, not integer. So strings are words, right? So we have the equal sign. So it checks if the value of the two operands are equal or not. So ABC does equals EFG. Well, this statement is true. We have not equal, which checks if the value of the two operands are equal or not. If the values are not equal, then the condition becomes true. So ABC does not equal EFG, so the statement's true. And guys, I think I misspoke. I meant to say is not true up here. Okay. Obviously, ABC is not equal to EFG, so it's not true. And this one is true because they are not equal. So we have dash Z, and this checks if the given string operand size is 0. If it is 0 length, then it returns true. Dash Z, A. So you would put Z first and then A. This is not true because A holds value. It has a string in it. Okay, so it's not true. Length is not 0. Dash N checks if the given string operand size is non-zero, meaning there is something in it. Dash N A. If it is non-zero length, then it returns true. So we see dash N A is not false. This is a weird way to word it. Okay, this just means it's true. So is not false, meaning it's true. And then we have str, and this checks if the string is not the empty string. If it is empty, then it returns false. So we have here, we could put str, a, and then is not false. And then we have some examples here again. Assuming a equals abc and b equals efg, we have some if-then statements. So the first one is a equal to b, then echo a is equal to b, else echo a is not equal to b. Okay, just as we saw in the above examples. So guys, in summary, we went over shell script features and capabilities, creating and running a script, working with variables, environmental variables, working with data types such as formatting, base conversion, and setting special attributes. We went over input and output techniques, conditional constructs such as if then, else, else if, and looping constructs such as for, while, and until, and basic operators. Next session, we're going to be going over manipulating strings, writing and calling functions, controlling process priorities, interpreting command line arguments, making scripts interactive, special shell variables, advanced I/O with streams, and improving performance of scripts. As always, be sure to follow these links if you're having trouble or you want a little bit more help with the concepts we're going over. There are weekly and monthly plans available for private tutoring sessions for system administrator management, as well as some private tutoring sessions for Linux and Bash scripting. Thanks so much for joining us, guys. This has been a course and session by coding-bootcamps.com. Looking forward to seeing you in session 4. What's up, guys? Welcome to session 4 of Introduction to Linux Bash Scripting. As always, I am your instructor, Kevin Downs. Today, we're doing session 4 of Introduction to Linux Bash Scripting Advanced Shell Features. Last session, we went over shell script features and capabilities, creating and running a script, working with variables, environmental variables, working with data types such as formatting, base conversion, and setting special attributes, input and output techniques, conditional constructs such as if-then and else-if, and looping constructs such as for, while, and until, and basic operators. Today, we're going over manipulating strings, writing and calling functions, controlling process priorities, interpreting command line arguments, making scripts interactive, special shell variables, advanced input-output with streams, and improving performance of scripts. We're going to start with manipulating strings here. So string manipulation is an operation on a string changing its contents. In Bash, string manipulations come in two forms: pure Bash string manipulation and string manipulation via external commands. Here we will touch on both types of string manipulation. So suppose that we have a variable in Bash holding a string we wish to manipulate. In the case that more than one string exists, we name the string string, string 1, string 2, etc. Also, we may opt to name a string something more meaningful than string to promote the understanding of the string content intended to use. And we can see that here. So string equals 1, string 2 equals 2, string 3 equals the value of string in string 2. Okay, so we actually make it equal to both of these, right? And we say, hey, echo string 3. And we can see we can have other ways of manipulating this. So strings equals 1 and 2. Okay, and we can echo string here. We can even say string equals A all the way to Z, so the whole alphabet. And for I, N, and then we have some code here. Do echo string. Done. Okay. It's going to say string A, B, C, D, E, F all the way to Z. Okay, so that's just kind of how we can manipulate strings here. Remember, strings are just characters and letters, okay, not integers such as 0, 1, 2, etc. So let's move on here to writing and calling functions. So a bash function is essentially a set of commands that can be called numerous times. The purpose of a function is to help you make your bash scripts more readable and to avoid writing the same code repeatedly. Compared to most programming languages, though, bash is a little limited in what it can do. So there's two ways to write a function, guys. We would use the specialized command function, and then we would put the function name, and then we would open the curly brace and close the curly brace. The other way to do it, and is the much more used way, is to just put the function name, and then we use a parentheses. Okay? So left parentheses, right parentheses, and then we do a curly bracket to open it, and then another one to close it. Okay? So let's look at that here. So we have our hash playing. We have variable 1 equals A, variable 2 equals B. We say my function, that's the name of it, and then we do the parentheses here, and we open it with a curly brace. Then we have all this code here, and then we close it with a curly brace, and we line it up with where the function name was, okay? And then we echo, before executing function, var 1, we put var 1 in var 2, and the value of var 2. And then to run the function, or call the function, is what it's known as. So putting it here, this is known as calling the function. Then it would run, and it would echo this, okay? So guys, if we were to run the script, here's what's going to happen. It's going to echo this, then it's going to call this function, so then it'll do all this, and then it'll echo this, so in that order. So it goes 1, does this, 2, it does this, 3, it does this, okay? Let's go ahead and talk about something else that's important for shell scripts, which is controlling process priorities. So the running instance of a program is process, and each process needs space in RAM and CPU time to be executed. Each process has its priority in which it is executed. The kernel stores a great deal of information about processing, including process priority, which is simply the scheduling priority attached to a process. Process with a higher priority will be executed before those with a lower priority, while processes with the same priority are scheduled one after another repeatedly. So guys, this is done through something called a nice value, okay? So nice values are a user space value that we can use to control the priority of a process. The values range from -20 to 19, where -20 is actually the highest, 0 is default, and 19 is the lowest value, okay? So we can check that out here. This may look familiar, this may look like top, but this is actually a little bit more interactive version called nmon, N-M-O-N, okay? But if we run top, we would see these same columns here. So we see this ni value, okay? And this is your niceness value. And I'll actually pull up my virtual machine here to show you guys here in a second. But we can alter this and change this to give certain things priority over the others. Here we have the top thing that we're normally used to, and we see we have a -12 here and -20. So this guy is actually going to get priority over all these other commands, and then -12, and then the rest would go one right after the other. Okay? And actually, this is good here. I don't need to show you my top command because here's the top command, the screenshot I took. Okay? Let's go ahead and switch to our next subject here, which is interpreting command line arguments. So passing arguments to a script, arguments can be passed to the script when it is executed by writing them as a space-delimited list following the script file name. Inside the script, the $1 variable references the first argument in the command line, $2 the second argument, and so on. The variable $0 refers to the current script. So guys, in the following example, the script name is followed by 6 arguments. So we have /bin, so we have ./bin/myshopping.shell script, and we give it apple 5, banana 8, fruit basket, and 15. Okay? And we're going to echo $3. So if we count here, 1, 2, 3. All right, 1, 2, 3. We get banana. And if we do the variable big equals $5, and we echo a variable big costs just $6, that will result with a, and we count 5 here, Okay. 1, 2, 3, 4, 5. A fruit basket, which is number 5, variable 5 here, costs just 15. Okay, because we said the variable 6 here, 15 is the last and 6th variable. Okay. So the variable $, hashtag, or pound holds the number of arguments passed to the script. Okay, so it's telling.
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
You how many arguments are passed to script. In this case, there are 6, right? Apple, 5, banana, 8, fruit basket, and 15. Okay, 6 arguments. And the variable $@ holds a space-delimited string of all arguments passed to the script. Okay. So we can also make scripts interactive. So an interactive shell reads commands for users' input on a TTY or terminal. So TTY means terminal, guys. So among other things, such as shell reads startup files on activities, displays a prompt, and enables jobs controlled by default. The user can interact with the shell. A shell running a script is always a non-interactive shell. All the same, the script can still access its terminal. It is even possible to emulate an interactive shell in a script. So here we have our hash pling, and we have the variable my_prompt equals $, and then just a blank space. So we say while nothing, do echo, and we echo the variable here, my prompt, and we say read line. So we're using the read command here, which is taking the user input and it's assigning it to the variable line, and we're going to evaluate the variable line, and done. We're going to exit. Okay. So let's actually look at special shell variables here. So Linux shell programming, there are special variables. The file name of the current script, and these variables correspond to arguments with which a script was invoked. Here is a positive decimal number corresponding to the position of an argument. The first argument is $1, second argument is $2, and so on. So the command line arguments, variable 1, variable 2, variable 3, all the way to 9 are positional parameters, with 0 pointing to the actual command, program, shell script, or function, and 1, 2, 3, all the way to 9 are the arguments to the command. So we can say echo file name 0, which is pointing to the actual command. We say first parameter is $1, 2. We can say quoted values, and guys, if we go back 1, remember this. We're going to go back 2 slides. It holds a space-delimited string of all arguments passed to the script. Okay, we'll go back to our original slide. We also have quoted values, and we have $*. Okay. And the total number of parameters. Remember, we go back 2 slides here. And that hashtag or # holds the number of arguments passed to the script. Okay. So these are all special shell variables here. Okay. Let's go ahead and move on to advanced I/O streams here. So a Linux shell, such as bash, receives input and sends output as a sequence or stream of characters. Each character is independent of the one before it and the one after it. These characters are not organized into structured records or fixed size blocks. Streams are accessed using file input-output techniques, whether or not the actual stream of characters comes from or goes to a file, a keyboard, or a window on a display, or some other I/O device. Linux shell uses 3 standard input-output streams, each of which is associated with a well-known file descriptor. We have standard out. This is the standard output stream, which displays output from commands, and it has the file descriptor of 1. We have standard error, which is the standard error stream, which displays error output from commands. It has the file descriptor 2. We have standard in, which is a standard input stream, which provides input to commands and has file descriptor 0. Guys, we talked about this in our last session as well, and we saw how to kind of move these and redirect these. Okay, this is important in scripts because it can be used to send things to other scripts or maybe files that are generated by scripts. Okay, so input streams provide input to programs, usually from terminal keystrokes, and output streams print text characters, usually to the terminal. The terminal was originally and guys, this word is pronounced ASCII or ASC2, ASCII or ASCII, sorry. So the terminal was originally an ASCII typewriter, a display terminal, but now it is more often a text window on a graphical desktop. Guys, we're going to finish out this session by talking about improving performance of scripts. So for better file handling, knowing or unknowingly, a lot of files are created or deleted in a shell script. Due to the use of a large number of files, handling of files becomes very important. Even a simple echo statement, which redirects output to a file, has to open the file first, write data into the file, and close the file. Use only the necessary commands inside a loop. It means not to use those commands which are not needed inside a loop, but it's common sense, right? The point here is, guys, just do not use commands inside a loop, which could be very well have been outside a loop, okay? Because we don't want extra memory being used or extra processing power being used if we don't have to, okay? We want these scripts to be as effective and as minimally resource intensive as possible. So whenever we have a requirement to write a script which is going to run on lots of files, the developer mindset is to write the script and make it work for one file. Once it works with one file, make it work for multiple files, either by adding a loop or by passing command line arguments. Lots of performance issues happens due to this reason, okay? And avoid the useless use of any commands. There's a problem term known as UUC, which stands for useless use of cat. This means use cat command when it's actually not needed at all. So if we don't need to use a command, guys, don't use it, right? If the script or something else is going to do it anyways, there's no need to throw this command in there, right? You're just using up more power than we need to. So in summary, guys, we talked about manipulating strings, writing and calling functions, controlling process priorities, interpreting command line arguments, making scripts interactive, special shell variables, advanced I/O with streams, and improving performance of scripts. Next session, we'll talk about editing a file from a script, scripting with ed or sed, Unix and Linux utilities to manipulate files, regular expressions or regex, grep and egrep, the stream editor sed, sorting in scripts, generating reports with awk, splitting large files, counting words, lines, and characters, transforming file contents, and extracting text strings. Definitely be sure to follow these links, guys, if you want a little bit extra help. We do have private tutoring sessions available for system administrator management, weekly and monthly plans. We also have Linux and Bash scripting with private tutoring sessions. Thanks so much for joining me, guys. Hopefully you're starting to get a little bit of firm grasp on how this scripting works with Bash. And I'll be looking forward to seeing you in session 5. What is up, guys? Welcome back to Introduction to Linux Bash Scripting. As always, I'm your instructor, Kevin Downs. This is Session 5 of Introduction to Linux Bash Scripting, a course by coding-bootcamps.com. Today, we're going to be going over text manipulation utilities. So in our last session, we went over manipulating strings, writing and calling functions, controlling process priorities, interpreting command line arguments, making scripts interactive, special shell variables, advanced I/O with streams, and improving performance of scripts. Today's session, we're going to be going over editing a file from a script, scripting with ed or sed, Unix and Linux utilities to manipulate files, regular expressions, also known as regex, grep and egrep, the stream editor sed, sorting in scripts, generating reports with awk, splitting large files, counting words, lines, and characters, transforming file contents, and extracting text streams. Let's go ahead and start off here with editing a file from a script. So the first one we got here is sed, which is that stream text editor, okay, which we just saw here. Okay, the stream editor sed. So here we see the format for this sed command. So we have sed, and then the patterns we want, so pattern 1, 2, on, and so on. And then the command and arguments here, okay? So here's an example of it. We have sed-i, and single quotes, we have s/gedit.desktop /yournew.desktop/g, and single quotation mark. Then we have a space, and we have /usr/share/application/defaults.list. So what's going on in this command here? Well, this is saying search in the file user share applications defaults.list, which is here, and saying find gedit.desktop, which is here. It's saying find this in this file and replace it with this, your new desktop. Okay. and apply the changes in place, which is -I. So in this file, search for this and replace it with this. Okay, so that's how we can use sed to kind of edit a file from a script. Okay, this is much more convenient than going in there, erasing the line, typing in the new stuff. We can do it in one line with the sed command, and it'll find it, it'll replace it, and it'll put this new line in there, okay? Now, at first, right now, you're probably thinking, well, it's probably easier to go in the text editor and just, do it myself, because I may be a little afraid or a little nervous of this command, or maybe I'm not totally comfortable with it. But once you are comfortable with command line in the sed command, this becomes so much faster and quicker and more efficient for you guys to just be able to zip this off in one line and edit the line in the file. So let's talk about scripting with ed or sed. So an ed script must contain commands to save the file and quit the editor. It produces no output to the screen except what may be generated by a specific command. The stream orientation of sed has a major impact on how addressing is applied. In ed, a command without an address only affects the current line. Sed is a stream editor. A stream editor is used to perform basic text transformations on an input stream, such as a file or input from a pipeline. While in some ways similar to an editor which performs scripted edits, such as ed, sed works by making only one pass over the inputs and is consequently more efficient. So we've looked at these commands before, guys, and these are ways that we can use utilities to manipulate files. These are the Linux commands which may help to create, delete, rename, move, copy, edit, and perform other related activities on Linux files. And we have seen these before, guys, and we've used them before many times. We have cat, which will list the contents of a file, touch, which will create an empty file. However, it won't let you edit it immediately. It'll only create that file, and then you're going to have to open an editor to edit that file. We have ls, or list, to list current files in your directory. mkdir, make directory, to make a directory. We have cd, to change directories. pwd, which is print working directory. We have rmdir, remove directory, to remove directories. We have move, copy, and remove. So move is how you can rename files or move files to another location while keeping or without keeping the file in the same location. Copy, on the other hand, can keep the same name or rename it, but will also create a copy of the file. Move does not keep the original contents. Okay, so it's renaming the inode on them. And then we have remove, and that's how we can remove files. Okay. We also have ln, which we haven't talked about too much, so we'll talk about it now. So ln is link. Okay. This is how we can create soft links or hard links. Okay. So guys, a hard link is merely an additional name for an existing file on Unix or on Linux or other Unix-like operating systems. Okay. However, soft link or symbolic link, unlike a hard link, does not contain the data in the target file. It simply points to another entry somewhere in the file system. So guys, a soft link points to another file in the system. However, it doesn't contain the original data, okay, where the hard link does. So I could delete a hard link or the original file of a hard link, and the data is still going to be there, okay? So I could go to the hard link and it's still going to be usable. A soft link does not have that original data, okay? So if I delete the original file, the soft link becomes useless. This becomes a problem in our scripts if we're using soft links and the file gets deleted, right? It's going to break our script. So let's kind of look at that real quick here to maybe show you what I mean a little bit more. So I'm going to head to my VirtualBox here. I'm going to log in. Okay, so I'm going to do an ls. Okay, you see I don't have the file test yet, so I'm going to touch a file just called test. Okay, ls. So now we see that test file here. I'm going to touch and create another file called test underscore link. We'll call it, actually, we'll say S-link for soft link or symbolic link, okay? ls. So now we see you have that test file, test soft link file, okay? I'm going to clear my screen real quick, do another ls so we have a little bit of space back. So now what I'm going to do is I'm going to do ls-s for soft link or symbolic link, okay? And then I'm going to put the file or the source file, and then where I want to link it to, test s link. Okay, oops. I need to spell it correctly. There we go. Okay. Okay. So I need to just go ahead and let it create that file. Okay, so we'll do ln-s. It didn't like that I already created the file, so we'll let it create the file. So test, let's say test underscore.
Thanks for watching. Please like and share this video.
Link. Okay, that's what we'll do. Alright, there we go. So now do an ls. Now we see this file here. Okay, notice it's colored differently, so we have a symlink now. So I'm going to clear the screen. I'm going to do a ls-l for long listing. Okay. You actually see here on my screen that's pointing to the file it's actually linked to. It's saying, hey, this is actually linked to the file test. Okay. I want to show you one more thing here. I'm going to clear my screen. Oops. So I'm going to do a link, and I'm just going to say test. I'm going to say hard link. Okay, I'm going to do ls. Oops. Now you see that this file exists. Okay. Now what I'm going to do here is I'm going to do an ls-i so I can see the inodes. Now what I want to show you here is notice that the inodes on test and test symlink are different. Okay, so they have different inodes. However, when we look at hard link and test, so I have hard link here, right? They have the same inodes, and why is that? Well, that's because, as I said, the hard link actually has the original data on it, right? So all the same info and same data is in there. The symlink, though, does not have the same information. So if I were to delete test, this symlink would be destroyed. If I delete test here, this hard link would still be usable. Okay, so that's important to know, guys, especially when you're creating scripts and they have links in them pointing to different files. Okay. Let's go and talk about regular expressions. So a regular expression is a string that can be used to describe several sequences of characters. Regular expressions are used by several different Unix commands, including ed, sed, awk, grep, and to more limited extent, vi. The sed command stands for stream editor, so S and then ed, stream editor. The stream-oriented editor was created exclusively for executing scripts. Thus, all the input you feed into it passes through and goes to standard out, and it does not change the input file. So an example of this, to search for the given string in a single file named test.sh, we can cat test.sh, or test shell script. And what we're going to see is the hash string here, a function, and the function just says echo, this is a test. We have a comment that says terminate our shell script with success message, and then we have an exit 1 error flag there, okay? And then we call the function. Okay. So from above the file, we can grep for exit, okay? So on my command line, I can type in grep, the string exit on a demo file, and the output would be exit 1, okay? Okay, so in this case, demo file would be this test.sh. So I could do grep, exit, and then test.sh. And it would find exit here, and the output would be, hey, I found this line here, and it says exit 1. So that's how we can use grep to find certain phrases in files, which is very useful when you're trying to find something. Let's move on to grep and egrep. Okay, so grep is used to look up regular expressions. Egrep is used to look up extended regular expressions. Okay, so we're going to kind of look at how both of those are used. So grep searches input files for lines containing a match to a given pattern list. When it finds a match in a line, it copies the line to the standard output by default, or produces whatever other sort of output you have requested with options. Though grep expects to do the matching on text, it has no limits on input line length other than available memory, and it can match arbitrary characters within a line. If the final byte of an input file is not a new line, grep silently supplies one. Since new line is also a separator for the list of patterns, there is no way to match new line characters and the text. The general synopsis of the grep line is, and we have grep, any options you want to put on it, the pattern you're searching for, and the file you're searching in. Okay? There can be 0 or more options, meaning you can have 0 options or no options, or you can have multiple options. And then patterns will only be seen as such if it wasn't already specified within options. So for example, we can use the -e pattern or -file options. And there can also be 0 or more input file names, meaning we can have no input file names listed, or we can have multiple, okay? So guys, all this is saying is that with grep we can have multiple options listed or none, and we can also have multiple files listed or none, okay? And up here it's just saying that when we do grep, it's going to go ahead and create a new line for us, meaning that when it finds one line of something, it's going to go and spit it out on the next line for you on your screen, as opposed to listing everything on one line on the standard output, okay? So let's kind of look at that here real quick with grep. Grep's a very handy feature in Linux. Okay, so I went ahead and made up a file here. So I'm going to do ls. We see this test file here. Okay, I'm going to cat that file real quick. So make cat test, just so you can see what's in it. It just says, hello, my name is Kevin. Okay, I'm going to clear my screen. So let's say grep. We're not going to put any options just yet. We'll say look for Kevin. Actually, you need to put it in quotation marks. I'm going to say the file is test. Okay. Now notice it didn't find that, and why is that? Well, because I put quotation marks. Notice what happens when I get rid of them. Okay. So, 2 things I want to point out here. One, notice it didn't find it the first time because I put in quotation marks Kevin. That isn't what's here. Second time, I put it lowercase and didn't find it because it's uppercase. Right now, when I spell it exactly as it is, it gives me Kevin. Okay? So you need to know that about grep. It's going to look for the pattern exactly as you supplied it. So if I do grep, quotation mark, capital K-E-V-I-N, test. Notice this time now it finds it, okay? So it's saying, or when we put these quotation marks, that looking at this as a string, saying, hey, you know, this is a string, don't interpret anything in here. So it found it because it's in capital, okay? Now I want to show you a useful flag with grep, or option, which is -i, which means case insensitive. So I'm going to type in Kevin this time, lowercase, the I option on there, and notice it finds it because the -i says case insensitive, meaning find all the words Kevin, whether it's uppercase, lowercase, it doesn't care. I just want to find this phrase in this file. Okay. I'm going to show you something else. Oops, I need to spell that right. Notice we also have these regular expressions down here. Okay. So if we do grep, exclamation point, test, notice that it supplied that whole line, even though it had other things on it, okay? So it's going to give you the whole line that it finds the phrase on, or the pattern. Okay. So let's go back to our PowerPoint here. Let's move to our next slide. So egrep is a pattern insertion command which belongs to the family of grep functions. It works the same way as grep-E does. It treats the pattern as an extended regular expression and prints out the lines that match the pattern. If there are several files with the matching pattern, it also displays a file name for each line. So the syntax for that is egrep, the options, the pattern you're searching for in the file, just like grep. Take note that the egrep command used mainly due to the fact that it's faster than the grep command. The egrep command treats the meta characters as they are and does not require to be escaped, as is the case with grep. This allows reducing the overhead of replacing the characters while pattern matching, making egrep faster than grep or fgrep. Okay. So guys, this is saying that characters such as backslash or a splat or star sign, it's saying when we use egrep, okay, it's not interpreting these as actual commands on the command line, because we could actually throw grep patterns in to search certain things. So for example, let me show you here. I could do a grep star, okay, and say, hey, everything that starts with a K or ends with a K, and test. Okay, it's not going to find anything because nothing ends in a K. However, if I flip that, K starts with a K, test. Okay. Notice it gave me everything, okay? So if I do a grep, let me clear my screen real quick. Capital K star test. Okay. So the dash E is used for extended regular expressions, meaning that we use meta characters to not interpret those, okay? So that command is the same as egrep. Oops. K star test. Okay, see, they work exactly the same. So here's some more examples of it. So we notice we have grep here. We can throw the options on it, the pattern we want to use, and the files we're searching it on. We have a dash A, which prints number of lines trailing the context after matching lines. We have dash lowercase a, which processes a binary file as if it were text. We have dash capital B, which prints number of lines leading context before matching lines. So dash B prints the lines leading to it, and dash capital A prints the lines after it. Okay, and we have dash C, which prints the number of lines of output context. It also places a line containing matches. We have dash lowercase b, which prints the bytes offset within the input before each file of output. Okay, so I can demo that real quick. So I can do a grep dash capital A Kevin test. Oh, okay. There we go. Okay, so let me actually clear my screen here. Let me do this for you again so you can see exactly what we're doing. Dash capital A, I'm going to say 2, Kevin, on file test. Okay. So I said grep dash A. I said show me up to 2 lines after you find the phrase Kevin, test. There's only 1 line total after Kevin, so it's only showing 1, okay? But if there were 2 lines after Kevin, it would show it. So I can do the same thing with dash B, say, hey, show me 2 lines before you find Kevin, test. And notice it shows me the 2 lines before Kevin, right? So if I do cat test, there you go. See, it's showing me the line that is, oops, that says is, and the line that says name, okay? So as you can see, grep is very handy, guys. Let's go and talk about the stream editor set. So the general syntax for set is as follows. So we have the pattern first, so we have / pattern and then / action. So here pattern is a regular expression and action is one of the commands given in the following table. If pattern is omitted, action is performed for every line as we have seen above. So guys, the / character that surrounds the patterns are required because they're used as delimiters. And remember, a delimiter is how the file or the script or the command we're using knows when to stop. So it'll see the delimiter you give it, and it knows to stop once it finds that. So we're going to look at deleting a line with sed. So to do that, we would first invoke sed. But as we see in this example, sed is now supposed to use the editing command delete line denoted by the single letter D. So we can do cat, the file we want to cat, which is etc password, and we can pipe that into sed and just give it the letter D. However, when we look at the next example, instead of invoking sed by sending a file to it through a pipe, the sed can be instructed to read the data from a file as in the following example. So the following command does exactly the same as the previous example without the cat command.
Thanks for watching. Feel free to add your questions as comments down below.
So we can actually just use sed by itself. So we have sed-e and then D and then the file. So we don't have to pipe things into sed. We can actually use sed by itself. Let's go ahead and move on to sorting in scripts. So sort is a simple and very useful command which will rearrange the lines into text files so that they are sorted numerically and alphabetically. By default, the rules for sorting are lines starting with a number will appear before lines starting with a letter. Lines starting with a letter that appears early in the alphabet will appear before lines starting with a letter that appears later in the alphabet. Lines starting with a lowercase letter will appear before lines starting with the same letter in uppercase. Okay? All this is saying, guys, is that it sorts it alphabetically, and before the alphabet words come, lines starting with a numeric number, or alphanumeric number, will come before lines starting with a alphabet number. So let's look at that. I can demo that real quick for you. So if we remember, in my test file, I have hello, my name is Kevin, exclamation point, question mark, and star. So if we do sort on that file, you're going to notice that it changed the order of that file. So the alphanumeric characters came first, and then it sorted it. Now off we go. So H-I-K-M-N. Okay. Guys, this may seem silly at first, but it's actually very helpful. Okay. So a command I use frequently is du-sh star, and I pipe that, du-sh star, and I pipe that in sort-n. So guys, what this tells me is I use this to go, that zero shouldn't be there. I use this command line to go into a certain directory or file system, and it tells me exactly what is taking up space, and it sorts it for me by lowest number to highest number. So if I run this, you'll see let me scroll up here. Okay. So you'll see it starts at 0, and then it goes to 4, 8, 24, all the way up to 6860, right? So we see there at the bottom, it's sorting it from lowest number to highest number, right? Okay, so that's super helpful to use the sort command in that way, right? Because otherwise, if I just did that same command, let me clear my screen. If I did that same command, notice they're all kind of out of order here. I have an 8, a 4, a 0. You know, it's just kind of, it's not as easy to read it that way, right? It's much easier when I do it the other way. Okay. And by the way, this command is a disk usage. It's telling me put it in human readable. And it's listing everything, so list all files, that star sign, okay? Let's head back to our PowerPoint. So as you can see, sort can be useful. So let's talk about generating reports with awk command. So awk uses a group of instructions called patterns, and patterns are applied to records. Records are blocks of data separated by a new line or any character defined in the rs variable. Fields are strings in a record separated by space or any other character defined in the fs variable. So how do you generate a report with awk? Awk is one of the most powerful tools in Unix used for processing the rows and columns in a file. Awk has built-in string functions and associated arrays. Awk supports most of the operators, conditional blocks, and loops. The basic syntax of awk is as follows. So we have the awk command. And then we have begin, so start action, the action, and then end, or the stop action, and then the file name. Okay. So here, the actions in the begin block are performed before processing the file, and the actions in the end block are performed after processing the file. The rest of the actions are performed while processing the file. So we have an example here. So we could do begin, then we say sum equals 0, and then we say sum equals sum plus the variable 5, and then we have end, which is print sum. And then we can execute it as follows. We could say awk-f, the sum column file, which is this, and then the input file. This will run the script in sum column file, and it will display the sum of the 5th column in the input file. Okay, so if we go back a slide, we had begin, which is our starting action, which was saying, hey, sum's going to equal 0. We had our action, which was sum equals sum plus 5, variable 5. And we ended it with our stop action. End, and then stop action is print the sum. Okay? And then file name. Okay? So splitting large files. To split large files into smaller files in Linux, use the split command. At the prompt, you would enter split, the options, the file name, and the prefix. Okay? So replace file name with the name of the large file you wish to split, and you will replace prefix with the name you wish to give the small output files. You can exclude options or replace it with either of the following. We could do line number, or we could do bytes, we could do -L line number, -B bytes. If you use the -L option, so lowercase l, you replace the line number with the number of lines you'd like in each of the smaller files. The default's going to be 1000. If you use the -B option, you would replace bytes with the number of bytes you'd like in each of the smaller files. Okay, guys, this isn't something that I use a whole lot, and you probably won't use it a whole lot either, but it is something good to know. We also have counting words, lines, and characters, so WC or word count prints a count of new lines, words, and bytes for each input file. The WC command, without passing any parameter, will display a basic result of any name.txt file, which includes the following. So it will give you the count number of lines, the number of words, the number of bytes and characters, and the display length of the longest line. So let's check that out real quick. And clear my screen here. So I'm going to do cat test, just so you can see that. So I can do word count on the test file. You see we have the number of lines, which is 6. 1, 2, 3, 4, 5, 6. Okay, number of words, which is 8. Okay. Number of bytes and characters, which is 29. Okay, it tells us the file was test. So it's counting these 3 as words, guys. So we have 1, 2, 3, 4, 5, and it's counting these last 3 as words. That's where we're getting the 8 from, right? Okay, let's go back to our PowerPoint. Now let's talk about transforming file content. So we can edit a file with Vim, as we know. So we would open a file with the Vim command. So for example, we could do vim etsy iscan int tscan.ini. We could type a / and then the name of value we'd like to edit and press enter to search for the value in the field. So with the sed command, you need to specify all the transliterations, and then you can choose which letters you want to convert. So I can do vim test. I can type a / here, and I'm going to move my screen down so you can see that /. So you see that / at the bottom of my screen here, okay? And I can type in KV, just KV, and I hit enter. Oh, I need to do capital KEV. Remember, it's case sensitive. Now you'll see it highlighted that for me, right? So I do a /KEV. You can see it highlights that for me. So that's a good way to search your text files. Obviously, this is a small file, so it's easy to find patterns in it, right? But let me exit out of this file. If I were to do vim on /etsy /passwd, Now, well, it's not so easy to find things, right? So if I do a /kev, well, now it's pretty useful, right? So I did a /kev and it finds the exact line with kev on it for me, right? So you can see how that would be useful. So we can also extract text streams. You can use grep with the -A, B, or C options, all uppercase. The -A switch will read the X number of lines after the match, so it is probably what you want. And the -B switch will read X number of lines before the match. Okay, we have an example of that on the next slide. We also saw that in our previous slides. So we can do a grep -A and a number, and we'll display the number of lines trailing the matched context. We can do a -B number, and it'll display the number of lines leading the matched line. And we can do a -C number, which will print the number of lines of output context. We also have another example of text extraction, which is substream extraction. So we can do string :position, and this extracts substrings from the string at position. You can also do string :position :length, like you extract length characters of substring from string at position. And here's an example of that. So we can say echo string z at 0, echo string z at 1, and echo string z at 7. You can also say echo string z at 7 and 3. Okay. So here we see the string, which is ABC, ABC, 1, 2, 3, ABC, and so on and so forth. So all different lowercase, uppercase, and different numbers. So if we do string z at 0, it gives us the whole thing. Okay. If we do it at 1, notice it chopped off that first A, right? And we can do 7, so it says, hey, start at the 7th position, right? String position, start at the 7th position. Okay. So here it's saying, hey, can we actually start from the right part of the string? However, you can't do that, right? It's just going to default to the full string. However, if we were to encapsulate that, notice that it'll actually work. It will start 4 from the right. Okay, guys, this isn't something really that's used either, but just be aware of it. This can be useful in certain scripts. Okay, so it's just another tool that you want to be able to be aware of when you're doing bash scripting. So let's go and close out our session here. So we talked about editing a file from a script, scripting with ed or sed, Unix and Linux utilities manipulate files, regular expressions, grep and egrep, the stream editor sed, sorting in scripts, generating reports with awk, splitting large files, counting words, lines, and characters, transforming file contents, and extracting text strings. Next session, we're going to go over Unix network applications such as remote execution commands, remote activity reporting, and communicating with remote users. We're going to go over internet applications such as FTP, TFTP, and telnet, remote access control mechanisms, and using the secure shell such as SSH. Be sure to follow these links so you can look at the monthly and weekly plans available for tutoring sessions for system administrator management, as well as Linux and bash scripting private tutoring sessions. Thanks so much for joining me, guys. This has been a course from coding-bootcamps.com. Looking forward to seeing you on session 6. What's up, guys? Welcome to Introduction to Linux Bash Scripting. As always, I am your instructor, Kevin Downs. Today, we're on session 6 of Introduction to Linux Bash Scripting. We're going to be going over networking commands. On our last course, we went over editing a file from a script, scripting with edersed, Unix and Linux utilities to manipulate files, regular expressions, grep and egrep, the stream editor sed, sorting in scripts, generating reports with awk, splitting large files, counting words, lines, and characters, transforming file contents, and extracting text strings. Today, we're going to be going over Unix network applications, remote execution commands, remote activity reporting, communicating with remote users, internet applications such as FTP, TFTP, and telnet, remote access control mechanisms, and using the secure shell, also known as SSH.
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
We're going to go ahead and start with Unix network applications. And we're going to talk about remote execution commands. So RSH, rlogin, and telnet. The rlogin and RSH commands for remote login and remote execution of commands are inherited from Unix. While some of them used because they are blatantly insecure, and this is so true, guys, these are not really used anymore, and if they are, I highly recommend that whether you're working with a client or your own setup, that you immediately find a better way to do your logging in, which is, in this case, can be SSH. SSH is really the new modern way to do it, which is secure shell. So just be aware that these methods are insecure, okay? So they still come with almost every Linux distribution for backward compatibility with Unix programs, okay? So these are backwards compatible to Unix programs. Telnet, on the other hand, is still commonly used, so Telnet's still commonly used, and it's often by system and network administrators. Telnet is one of the most powerful tools for remote access to files and remote administration, allowing connections from anywhere on the internet. Combined with an X server, remote graphical applications can be displayed locally. There is no difference between working on a local machine and using the remote machine. Okay, and guys, in this case, X server just means any server. You can combine it with a server to get it set up, okay? Let's go and talk about FTP here. So the standard FTP, or File Transfer Protocol, so that's what FTP stands for, is the original FTP client. It comes standard with most Linux distributions, and it first appeared in the 4.2 BSD, which was developed by the University of California, Berkeley. It's easy to use FTP, and let's say you want to connect to the anonymous FTP site metalab.unc.edu to download the latest Linux kernel source. So at the command line, you would type FTP, that metalab.unc.edu, and the FTP program will attempt to connect to metalab.unc.edu. Another way to do this is to run FTP from the command line with no parameters and use the open command with the site name as an argument. So you can use FTP, a prompt would pop up, and you can run this command here, alright? Now I can't show you this on my machine because it's not really set up to connect to external websites. I don't have an FTP server that I can connect to that can relay these commands, okay? But just be aware that you can grab files from websites using this FTP command. There's also TFTP, and this is Trivial File Transfer Protocol, and this can be used to transfer files to and from remote machines, including some very minimalistic, usually embedded systems. The remote host may be specified on the command line, in which case TFTP uses hosts as the default host for future transfers. The TFTP protocol provides no provisions for authentication or security. Therefore, the remote server will probably implement some kind of access restriction or firewalling. These access restrictions are likely to be site and server specific. Okay, so you have to secure them somehow. And this is likely specified on the server itself. Alright guys, very briefly, we're going to talk about remote access control mechanisms. So we have X security and X display access control. So X provides mechanisms for implementing many access control systems, and the sample implementation includes 6 mechanisms. We have host access, which is simple host-based access control. We have MIT Magic Cookie 1, which is shared plain text or cookies. We have XDM Authorization 1, which is secure DES-based private keys. We have Sun DES1, which is based on Sun's secure RPC system. We have MIT Kerberos 5, which is Kerberos version 5 user. We have server interpreted, which is server-dependent methods of access control. All right. Now, guys, this is kind of the bread and butter of how most people will access servers, which is SSH, or Secure Shell, and is a protocol used to securely log on to remote systems. It is the most common way to access remote Linux and Unix-like servers. And I can vouch for this. This is how I log into all my servers that I work on daily. The tool on Linux for connecting to a remote system using SSH is called, unsurprisingly, SSH. The most basic form of the command is you use SSH and then the host you're connecting to. The remote host in this example is the IP address or domain name that you're trying to connect to. And typically, guys, if you're going to type in a host name, that means that host name is specified in your host files, and the IP is listed there. If it's not, and you try to type in a host name, it's not going to know what you're saying. It won't be able to resolve it, so you'll have to type in the IP address. Okay? So if your username is different on the remote system, so you're on your current system, and you're trying to connect to another system, but your username is different on that system, you can specify it by using this context. So you do SSH, the username on that system, @ and then the server you're trying to connect to. Okay? If it's not a different username on there, you can just go ahead and do SSH and then the remote host. Okay? Once you have connected to the server, you will probably be asked to verify your identity by providing a password. Which it should. That's part of a secure system, right? It should always ask you for your password unless you have some type of SSH key set up. So in summary, guys, we talked about Unix networking applications such as remote execution commands, remote activity reporting, communicating with remote users. We talked about some internet applications such as FTP, TFTP, and telnet, and remote access control mechanisms and using the Secure Shell or SSH. Be sure to follow these links so you can check out the weekly and monthly plans available for private tutoring sessions of System Administrator Management, as well as private tutoring sessions for Linux and Bash scripting. Be sure to continue your trading. We have other courses to look at, such as Intro to Cybersecurity, Introduction to Cloud Technology, learning how to manage Windows servers, Introduction to Database, learn SQL programming with examples, Introduction to NoSQL database design, and learn graph database design by examples. Check out these resources. We have a comprehensive list of all Linux OS distributions available. We have an overview of Linux file systems. You can take a look at what mechanisms are behind the Linux kernel task management and how Linux kernel sources and functions work. We also have a comprehensive look at how Linux data source structures work available, as well as a comprehensive review of how Linux file and directory system works available. A comprehensive list of all special purpose Linux distributions are also available. And finally, we also have a comprehensive list of all secure Linux distributions for cybersecurity professionals available for you as part of this course. Some classes to follow up with after this course are Learn PHP Programming, Advanced Linux Bash Scripting, which is another course I'll be taking, or instructing, Linux Management for System Admins, which is another course I'll be instructing, and Intro to HTML and CSS. Thank you so much for joining me, guys. I hope you learned a lot in this session. We're not quite done, though. Don't forget about those labs and hands-on projects we're going to have you do. But thanks for joining me, guys. This has been a course by coding-bootcamps.com. Be sure to follow us on Facebook, LinkedIn, and other social media platforms. Looking forward to working with you guys on the projects. Good job, guys. You've completed Intro to Linux Bash Scripting. I want to congratulate you on completing the course and finishing the projects and guidelines. Let's go ahead and go over some things that we covered. So we went over basic user commands, intro to shells and fish bash scripting, shell programming, advanced shell features, text manipulation utilities, and networking commands. We also did a couple projects. We did a bash scripting project with 12 hands-on examples, and we did a grep command project with 10 hands-on examples, and you completed that homework, and you wrote your very own script. So again, congratulations on completing this course, but don't stop here, guys. Continue your learning. Continue to enrich what you've learned. Seek out more projects. Follow some of our other courses, some of those resources we linked for you. Be sure to keep reading and doing more projects so you can cement these ideas in your head. Definitely take some of these follow-up classes, such as Learn PHP Programming, intermediate level Linux Bash scripting, so that'd be a good one to take immediately after this, and that will be a course that I instruct as well. And then Linux Management for System Admins, which will be another course that I instruct, and Intro to HTML and CSS. So guys, again, congratulations. Be sure to follow us on social media such as YouTube, LinkedIn, Twitter, and other social media platforms. Again, this has been a course by coding-bootcamps.com, and I look forward to seeing you in some of our other courses.